Hi, Thomas. It's good to see you. Thanks so much. Oh, thank you. Great.
Steve, John, there's a package of today's materials. Okay. Good afternoon, ladies and gentlemen. Good afternoon. Welcome back to Washington for those in attendance, and for those on the conference bridge, thank you for dialing in today. This is our fifth meeting of the Task Force on Optimal PSAP Architecture. We have a full slate of things to get to, so we're going to get right into it. The materials that are being presented today are or should be posted on the FCC's website. You can get there through the events webpage. And then the reports, on the assumption that a vote will take place today, those reports will be should be available by the close of the meeting. With that, I would like to introduce David Simpson, Chief of the Public Safety and Homeland Security Bureau.
Great. Well, thank you, Tim, and thanks to everyone for collecting today. Welcome to the fifth meeting of the FCC's Task Force on Optimal Public Safety Answering Point Architecture, or PSAPs. Since our inaugural meeting at the beginning of the year, you've devoted your time, service, knowledge, and expertise to this important work of the task force, focusing on the troika of next-generation 911 deployment: optimal resource allocation, optimal cybersecurity, and optimal next-generation 911 system implementation, recognizing that those are interdependent with each other and that there are decisions within each that will result in an optimal overall way ahead for each local jurisdiction, each state to make decisions around. At our last meeting in September, Working Group 3 presented its report and recommendations addressing the challenge of funding 911 systems as they transition to next-generation architectures, but also as the underlying transport transitions to packet-based technology. Today, you will hear presentations and conduct a vote on Working Group 1's recommendations on optimal cybersecurity and Working Group 2's recommendations regarding optimal 911 system implementations. These reports arrive before you at a critical time. As Chairman Wheeler described at APCO's annual conference in August, and again just a few weeks ago in an op-ed that ran in the New York Times, the nation's 911 system is literally the envy of the world. It's the best. However, that technological advancement I talked about on the underlying carriers, the developments in smartphone technology, advancement in the proliferation of broadband technologies, ubiquitous availability and the use of wireless devices, and growing and diverse cyber threats targeting Americans' everyday communications tools demand that the system adapt. Chairman Wheeler stressed that state and local leaders want to move to next generation 911 and understand the pressing need, but there are understandable reasons that the transition has lagged. Running day-to-day operations in and of itself is an all-consuming challenge. And during the transition to next-generation 911, state and local 911 authorities must continue to support legacy operations while also investing in new technology and workforce training, really in living in a hybrid world until such a time as we're able to retire the legacy. This increases cost and complexity at a time when our public safety resources are already stretched thin. The work of this task force promises to lend guidance to those judgments that decision-making officials have to make about moving forward and to provide real tools for making the hard decisions confronting state and local decision makers. The report will also influence what the FCC works on and we look very forward to hearing your recommendations in that regard. Before the presentations begin, I'd like to take a moment to thank APCO's Jay English, Working Group 1 Chair, for their hard work within his group. I'd like to thank the National Association of State 911 Administrators and Pennsylvania 911 leader himself, David Hall, who is the Working Group 2 Chair, for the hard work that he's put into this and for his group. In both cases, outstanding leadership over the past months where the real heavy lifting has taken place. In the space of less than a year, Jay and David marshaled the expertise of their working group participants to provide thorough study of the issues and to craft substantive guidance documents for state and local decision makers. That is where these reports will have the most impact. The issues are complex, challenging, and evolving, but Working Groups 1 and 2, as well as the work that Phil Jones led in Working Group 3, have laid down a firm foundation as we move into the new year. Let me pause for a moment here and put the importance of your work in a little bit of context as we, as a nation, all recognize that while for many years we have fought terror and terrorism overseas, that just as it did 9/11, just as it did in Paris recently, terrorists see our country and communities within our country as part of their target set. And as happened in San Bernardino, we will face, unfortunately, again, the need to discover and respond to the actions of terrorists. That front line of that discovery and that action, it's a community front line. What we're working on here to achieve the capabilities of Next Generation 911 has the potential for being immensely helpful in that discovery and that rapid characterization and appropriate response to a terrorist attack. We ought not, however, lose sight of the potential that because of the value that 911 has in the response to a terrorist attack, a natural disaster, an emergency, it in and of itself may be the object of terrorist attack. It may be part of a layered attack. And it could come through a physical attack to 911 infrastructure. It could come from a cyber attack from half a world away. Regardless, we have work to do as a nation. We have work to do within communities to make sure that 911 is an asset to help identify and hopefully avoid, but identify where we can't avoid and mitigate the suffering associated with a terrorist attack. So the work that you've done, the work that you continue to do, has a national imperative. It's high-quality work. I commend you. And we look forward to continuing to engage in this public-private partnership that serves the FCC's mission, but more importantly serves the mission of each of your communities to help ensure the optimal and timely implementation of Next Generation 911 nationwide. Thanks. Steve.
Good afternoon, and thank you, Admiral, for your kind remarks. If I could build on that for just a moment. As I was talking to the Admiral before the meeting, I said to him, if he did not mind, I was going to comment on the events of the last week and a half with regards to what happened at Colorado Springs and what happened a week ago in San Bernardino. Those events, as horrific as they were nevertheless reported to public safety by one person calling 911. And it points out yet again how critically important what we're doing here on this task force is to our nation as a whole and to those absolute first of the first responders that answer those 911 calls and those responders that respond to those 911 calls. Our work is critically important, highlighted by what happened recently, but also highlighted by whatever happens every single day and is happening even as I speak. So, Admiral, thank you for recognizing that, and my hats go out to all 911 centers, and because they are recently in our mind, particularly to the 911 center that serves El Paso County and Tyler County, Colorado, and of course San Bernardino County or San Bernardino City, California. Welcome again. We don't have a full house at the table, but that's understandable. But I appreciate, as does the Admiral, all of you that attended today. We will take roll call in just a moment, but for those of you that are on the bridge, please know that you're missing a beautiful 60-degree December day in the nation's capital. It is almost as if it were spring. So we miss you, but you're missing some wonderful weather as well. Let's begin over here on my left, and we'll go around the table and reintroduce ourselves. Brad?
Hey, good afternoon, everybody. It's Brad Blanken, CCA.
Joe Heaps, Justice, NIJ.
Brian Fonce, National Emergency Number Association.
Robert Brown, NIPSTIC.
Mario Durango, Motorola Solutions.
Jay English, APCO.
Dave Hall, the National Association of 911 Administrators.
Lori Flaherty, National 911 Program.
Mary Boyd, West, formerly Entrado.
April Heinze, Michigan Communication Directors Association.
Tony Montani, Verizon.
Chuck Vick, Verizon.
Alicia Burns, The Digital Decision.
Jeff Whittick, Airbus DS Communications.
Roger Hickson, NENA Technical Director.
Phil Jones with the Washington State Utilities and Transportation Commission, way here at the other end of the table.
Dusty Rhodes, Department of Homeland Security.
David Firth with the FCC.
Tim May, Designated Federal Officer.
And we'll go to the bridge. Anyone lead off, please? If somebody spoke, we didn't hear you.
I bet Dana can start.
Phil Jones with the Washington State Utilities and Transportation. Right here at the other. Dusty Rhodes, Department of Homeland Security.
Oh, that's a late echo.
Designated Federal Officer.
If you could hold your microphone or your phone closer to you.
Gina Green with Sprint.
Jim Gerke, Texas 911 Alliance.
We didn't hear you. Ron Bloom, Frontier Communications.
We certainly want
Gina
to
Green with Sprint.
Jim Gerke,
Texas 911
Larry Hatch, Oregon APCO NENA.
I trust we have everyone, and it's important that if you comment throughout the meeting that you try to get that microphone as close to you as possible, and we would greatly appreciate it if you would mute your devices until such time that you'd like to comment. Thank you again.
This is Tim. Just to point out, there is a delay in between on the webcast, so if you don't mute your phone, we're going to hear the 10 or 15 seconds later the progress of the meeting. So please mute your phone. Thank you.
Thank you, Tim. The last 3 months of the task force have been extraordinarily busy. I can attest because I have been a part of some of the calls, certainly not all of the calls that work group number 2 and work group number 1 have engaged in during this last 3 months. And for those of you that have the product of their effort before you on screen or in hard copy, I think the volume itself speaks to their effort. We have a lot of work to cover today. We're going to lead off with David Hall and work group number 2. And David, thank you again for your effort and all those that helped you. And please proceed.
Thanks, Steve. And I want to thank also Admiral Simpson for the opportunity, Tim May, David Firth, and I know he's not present today, but Michael Connolly, who painstakingly attended most of our conference calls over the past 12 months and was the advisor to our group. The report that you have before you today for Working Group 2 is the culmination of almost 12 months of work. It involved over 40 conference calls by the members, and that's 40 plus in some cases members. Some were not on attendance of all calls naturally, but when you calculate out the attendance hours, it's well over 1,000 hours that were spent by all of those collective folks on the phone working through this process. And that does not include the subgroups, because as you'll see, and as you may have heard in past reports, we've divided a lot of this work down into individual subgroups as well. We went through a journey. We started with the charter that was provided us, and in that process realized that it was a broader, bigger undertaking than we first initially thought, because our task was PSAP architecture. And we realized early on, and became a formidable piece of our discussion and our presentation, and you'll see that as we go through today's group, that it really is about 911 system architecture. It is bigger than just the PSAP. The PSAP is an important component of that, but really in a next-gen 911 world, it's a much more. It talks to the environment, and you'll see some of that depicted, and you'll hear some of our various members talking to those various points as we go through this today. The report itself is going to be done by a number of the members. In many cases, as we divided it out, there were subgroups within the working group. I will be doing section 1 and 2, which is the executive summary, the introduction, and then I will turn for section 3, which is the current PSAP decentralized environment, to Mary Boyd to talk about, and then PSAP optimization environment, Mario Durango and Jeff Wittick will speak to, Esinet, the ESInet optimization considerations and factors, Chuck Vick will speak to, then access and NG911 core services implementation, which is a critical component of this as well. Roger Hickson will speak to. Lori Flaherty will speak to the governance portion. And then Tony Montani and I will come back and speak about the next Gen 911 planning and transition considerations for 911 authorities. And then in the end, I will sum it up with some findings and considerations as we move forward. So that being the case, we'll start off talking about public safety answering points. They are really the gateway, as you heard Steve mention earlier, and everybody said, when someone needs emergency service, you call 911. It's a 3-digit number that's now been with us for many years and has become part of our national culture when it comes to summoning emergency responders. There are well over 5,900 PSAPs across the country, and more than 240 million emergency calls annually are made to those PSAPs nationally. While 911 continues to perform admirably, as Steve mentioned earlier, it is, and as the Admiral mentioned, it really is the envy of the world in how we do that. It is presented, however, a bunch of new challenges moving forward. It was founded on a technical principle known as time division multiplexing, or TDM. It was circuit switched voice services technology that's now it's over 40 years old. It started with wireline. You're all familiar with having that phone at home that worked on a wireline principle, hardwired back to a central switching point with the phone companies. But that is the legacy system. Internet protocol networking-based technologies are now rapidly replacing that TDM legacy system. So we refer to it as the TDM to IP transition. And that copper infrastructure that was based off the circuit-switched voice technology is rapidly being replaced by IP-enabled solutions. It's estimated that as of November 2013, some sources said that 38% of all households currently rely on wireless and not wireline. as their primary source of phone service. And that reliance results in about 70% of all 911 calls across the country. And this varies by jurisdiction. Some it's actually greater, some it may be less, but that's an average. About 70% of all 911 calls are being placed from wireless phones to 911 centers. Despite that, the capability that we all have with our smartphones, with multimedia capabilities, VoIP devices, most callers cannot rely on that. In some limited jurisdictions, they can use text. But in most jurisdictions, it goes back to, again, voice communications. Legacy 911 systems, the TDMs, as we talked about, are not capable of receiving those various forms of multimedia, commonly called what everybody uses today, essentially. So 911 authorities that have operated on legacy systems have relatively been independent and isolated. That's just the technology. It's the way the technology works. Implementation of the next gen into that next gen environment will require, we have understand significant changes to both the roles and the responsibilities within 911 and within that environment. So in our report, we introduced an expanded nature of that next gen 911. And we term it's the originating service environment. In the legacy system, it was referred to as the originating service providers, which were largely the carriers and the telcos. But there will be a lot of input coming from a lot of different areas aside from those carriers as we move into the next gen. So it's more of an OSE as opposed to an OSP. And we'll get more into that as we go through our report today. But that environment includes IP call setup. It includes location determination, validation, delivery to ESI nets, and then ultimately to PSAPs across the country. The implementation of next-gen 911 architecture will require many 911 authorities, and that's a concept that we introduce in the report as well. It's not just PSAPs, it's 911 authorities, however they evolve through local systems or state systems, to begin evolving a vision. And that vision has to be collaborative as they develop new models across the country for these service deliveries. It's developed with the intent to help clarify and educate decision makers. And those decision makers are going to be tasked with that critical responsibility to move into next generation 911 from the current legacy system. So working group divided our work into 4 distinct areas of that emerging next gen 911 environment. The first was the Emergency Services IP Network, or the ESI net. The second was Access and NG911 Core Services, the NGCS, since we all like acronyms in this business. And PSAP terminating equipment, call-taking support systems, which could include things like your computer-aided dispatch, your management information systems, your dispatching equipment, a whole variety of other different component pieces to that terminating equipment support piece. And then finally, the governance piece. Because the governance piece, since we are moving from independent, isolated systems into more of a convergence of collaborative systems, that piece becomes absolutely critical as people reach outside of their own PSAPs and start working with other folks in 911 authority systems. So one of the diagrams, and you've seen this before, and I know Working Group 1 has worked with their cybersecurity, has worked off of this as well. These are the component pieces that I just mentioned, and this was the first place that we started looking. And then when you take a look at configurations, there's a variety of different ways that all these component pieces can be configured. So we laid the variety of those things which you'll hear talked about here today with the configuration options for the various component elements. So the development and implementation of a standardized, nationwide, interconnected system of systems, and that's how we're looking at this for 911 emergency communications, will need to evolve. And in that transition, end states can allow support significantly enhanced, and things like redundancy, real-time alternate call routing will take place, improved call transfer capabilities will need to take place. Multimedia capabilities, including those as a part of the PSAPs, what they can receive and what they can send will have to take place. And there will be additional data. and a lot of backup improvements as part of that system. So this report will discuss several potential architectural models for transitioning, as we have said, 911 authority systems into the next generation environment. It will also explore some of those basic operational and architectural models that are available. It'll talk about the components, we'll talk about the requirements, we'll talk about the challenges, and we'll talk about the opportunities as well that will be associated with that deployment of those systems. There's a significant focus on the options for maximizing cost effectiveness and efficiency, because we think that is one of the key pieces that will come into play here as well. So there's a new paradigm of next-gen 911, and it will be based upon the system roles in emergency services, what we call the ecosystem. And that ecosystem is depicted essentially by this graphic, which talks about, again, as I've already mentioned on the side, the originating services environment, and a number of acronyms that are listed there in terms of how calls originate, what sources they originate from, multimedia sources as well as traditional voice services, and how they then go from an IP environment or a TDM environment into a core services piece, and the variety of components within that core services that also are part of determining routing, which is the geographic information system piece there, and that feeds that out to extended networks and or to PSAPs. And radio networks are part of that, one part of that anyhow, but there's additional networks in terms of how that gets fed out of that system. But we see this as what we call the ecosystem for next-gen 911. So what are the new roles and responsibilities? Well, inevitably, they will include, as I had mentioned, going from OSPs to OSEs. The next generation core services are developed as well. And you will see how some of those core services, not in the isolated sense that where a PSAP had all of their services contained within that PSAP associated with the carriers, what we will see in the next generation evolution is that there will be not as much isolation, more collaboration, cooperation with all those component pieces I just mentioned. So 911 authorities existing in that legacy environment will also change as they broaden their roles and their responsibilities into more multi-jurisdictional, regional, statewide, or even in some cases, depending upon the states, multi-state relationships or cross-border relationships that will occur. Here's a roles and responsibilities view. Again, the OSE to the next Gen 911 core services in its relationship to the PSAPs with regional or state authorities and the 911 services system providers and then the local authorities there. So, and a variety of different configurations and ways that this can all play out. So deploying next generation 911 is not a question of if, it's a question of when. When is it going to occur? How's the transition going to take place? And that will be dependent upon a lot of decisions made by local authorities and or 911 authorities in terms of what their plan is for the evolution of their systems. But a primary message in this report is that the architecture can be customized to support almost any configuration based upon a number of factors. And you'll see us talk to the factors such as financial factors, political factors, governmental factors, and operational considerations as well. So with that, I would turn to Section 3, and Mary can talk about the current decentralized environment.
Okay. You're going to drive, Dave, is that right? You want me to?
It'll be easier. You just.
Okay. Good afternoon, task force members and guests. As Dave indicated, Section 3 is really about the current legacy environment. We thought it important that we capture for the reader of this report really what the legacy environment looks like, the types of calls that are coming into it. We didn't assume that we would have all experts reading the report. So this section is dedicated to a short overview. And in the current environment, most of all the PSAPs are decentralized in the sense of they're operating with their equipments within their PSAPs, their networks. They're pretty much an autonomous entity when it comes to looking at statewide 911 systems. And so we spent some time identifying really the network, and you'll see in the report as Mario gets into it, the comparison between what the legacy network looks like to an IP network and what that affords the public safety agencies as they advance in the technologies. With the legacy environment, we also see operationally is also, as 6,000 of them grew over the last 30 years, they were developed to meet the needs of their local jurisdictions. With that, they have agencies that they respond to. If you compare that to a next generation IP environment, then you're able to build additional resources and collaborate. But in the legacy environment, there's limitations even in how they manage their 911 calls. We identify in Section 3 the types of calls that are coming into the PSAP, but today they're only limited in terms of sending telephone number and location from a primary to possibly a secondary. But if they leave the boundaries of their jurisdiction within their 911 footprint, then they become very limited in what they can send forward. And we thought it important that for a 911 authority or a policy official that was looking at why do we want to consider optimizing our networks, that we explain those limitations that the systems have today, but also reinforce they function very well, but there's opportunities to gain some economies of scale. And as we moved into Section 4, we want the reader to understand that when we talk about optimizing a 911 network, sometimes that gets translated to consolidation. That's not really the case. But to look at optimizing the network, it gives them perhaps even improved operational efficiencies, but they also need to explore the financial aspects of that, and then the political elements become a little more complex, but they are all very viable as you come to optimizing in a next generation environment. And we capture in 3 to get the reader ready that for the next section that these benefits go into shared systems, not only technology and cost efficiencies, but also operationally from sharing personnel. And the PSAP sub-team that Dave referenced really focused on Section 3 and Section 4, and I really want to thank all the public safety experts that were on our team and helped us in the development of this language. But as we move from the legacy environment, we capture, and I'm going to turn it over to Jeff. Jeff, where are you? There you are. I'm going to turn it over to Jeff to really talk about in Section 4 the benefits of when you begin to optimize your 911 networks. And Jeff, do you want me to? I'm going to hand this down to you. Sorry, guys. Stand by. Get that technology. Yeah.
Thank you, Mary. Good afternoon, everyone. So as Mary said, in Section 4, we're going to begin to talk about and document optimization. As the working group and the subgroups started their work on Section 4, it quickly became apparent that there is a heavy interrelationship between the NG911 core services, the ESInet, and the PSAP infrastructure and PSAP services. Section 4 only deals with the PSAP infrastructure and services. The NG911 core services and the Esinet we chose to break out and to document those in subsequent sections, just for the reader so that they understand. A couple of other things I'd like to point out is that while deployment at a county, regional, or state level of 911 core services and everything that goes with NG911, it's immaterial at what level those services are deployed. The fact of the matter is the economies, the efficiencies can be realized whether NG911 is deployed at a regional, state, or county level. All of those deployments will allow the PSAP to take advantage of and configure call flows and applications so as to efficiently handle their operations. Additionally, it's important to note that customer premise equipment, or what has traditionally been known as customer premise equipment, may be now more accurately called call processing equipment, can be deployed within the PSAP, but no longer has to be. It doesn't have to be within the confines. And it also does not have to be any longer from a single manufacturer. Particularly, it is likely in larger multi-agency deployments that there could very well be multiple manufacturers involved in the deployment. As the working group considered the specifics of optimization, it realized that optimization is not purely a technical matter. Operational optimization is equally important and must be considered as the jurisdictions and 911 authorities choose the most appropriate deployment for their needs. NG 911 will allow PSAPs to collaborate as never before. PSAPs will have the ability to organize and coordinate operations so as to assist one another during periods of high volume or service outages. The working group considered several operational optimization models and documented those in Section 4 of the report. Those models consist of centralized shared services, hybrid services where you may have centralized call taking but distributed dispatching, services consolidation by discipline where centers may operate police, separate fire, separate EMS, or additionally a virtual arrangement where services are distributed across the enterprise but operate in a coordinated fashion. Mario Durango is now going to describe for you the technical infrastructure architecture models.
Next slide, please.
Yep.
Good afternoon. So Jeff talked about the operational architecture. I'm going to dive into the technical architecture for PSAPs. These next three slides depict three technical architecture alternatives for deploying next-generation PSAPs. Before I compare and contrast these architecture options, let me describe some of the common technology components that will be seen in each of these alternatives. The Esinet, as we know, is the IP transport network that the NG 911 core services use to route and deliver emergency requests made by 911 callers to the appropriate PSAP. Moving into the future, it should be recognized that more and more emergency events will be initiated not by individuals dialing or texting 911, but by PSAPs processing additional new information sources. These new information sources include Internet of Things sensors, social media feeds that must be ingested and processed by real-time data analytics or predictive analytics services to determine, for example, that a gunshot has occurred and its location, or that bridge sensors warn of an impending structural failure, or that local Twitter feeds indicate that gang activity is about to occur or has already begun at a specific location. A further source of information are the video surveillance cameras that are being deployed in public locations. And that, when coupled with video analytics, can determine, for example, that a serious vehicular accident may have occurred on an otherwise deserted intersection at 2 a.m. and would have gone unreported indefinitely otherwise. These new sources of potential emergency context may overwhelm the existing PSAP telecommunicators, and therefore a new PSAP role is shown, that of an analyst, who will examine the often imperfect analytics outputs and determine if an emergency event has indeed occurred and can then initiate an incident, much like a traditional call taker. The analyst can also play a significant role mid-incident by using the intelligence gathered from these additional data sources to provide a more effective resolution to the incident. The other technologies that will be seen as common in each of these architecture diagrams are the leverage of client-server computing and server virtualization, both of which are prevalent in the broader internet and IT industries today. PSAP telecommunicator workstations will be equipped with application client software that will request services from application server software components running on server hardware that can be distributed across an IP network. This is the method used by service-oriented architectures and the emerging microservice architectures being deployed today for web services. In each of these architecture models, multiple application service components are shown efficiently sharing a common pool of server and storage hardware through the use of virtualization software. This virtualization software creates independent virtual machines or very lightweight containers that the services can run in, maximizing the utilization of those hardware resources. These technologies are the same key components used for deploying highly cost-effective, highly scalable, highly available cloud services, even if deployed in a purely private government network. Now let's examine the three architecture alternative models. In the first model, as shown on the slide, the PSAP has deployed all its necessary application services, such as call taking, CAD, records management systems, to name a few, on-premise within the PSAP facility. In this model, these services are dedicated solely to use by this one PSAP. The PSAP can still enjoy the benefits of a client-server model and server virtualization, but since the PSAP is reliant on these dedicated services, the computing hardware that runs them must be scaled to support the peak emergency load that the most major incident within that jurisdiction can produce. Also, since the PSAP facility itself may experience failure due to a natural or man-made disaster, there must be a redundant backup facility, although not shown, that again must be equipped with a full scale of computing hardware to support that peak load of emergency requests. So this option can be costly from a facility and equipment standpoint, with the bulk of the PSAP computing resources remaining inefficiently utilized during typical days. Next slide, please. In this second architecture deployment alternative, multiple PSAP jurisdictions have chosen to share the server-side infrastructure components, and these components are shown housed in separate data center facilities. A logically equivalent sub-option would be that one PSAP facility, or two or more for redundancy, support the deployment of the shared infrastructure services, negating the need for a separate data center facility. In either case, each PSAP can retain its local telecommunicators and need only equip their workstations with the appropriate client software in order to access the shared infrastructure services across the ESI net. By sharing services, the amount of required server computing and storage hardware can be dramatically reduced in aggregate compared to the first architecture option in which there was no sharing by each of the PSAPs. That's because major incidents that are typically localized to a single jurisdiction can be easily absorbed by the significantly larger scale of shared service infrastructure used in this model relative to that of any single PSAP in the first architecture option. In fact, the cost and scalability benefits increase with the amount of PSAPs that choose to share infrastructure. Interoperability is also improved in this option because the PSAPs are using a common or compatible set of shared application services. If one PSAP is knocked out by a natural or man-made disaster in this option, 911 traffic can be routed to any other PSAP whose telecommunicators should be familiar with the PSAP call taking, CAD, records management services, logging services, etc., and should be able to pick up the redirected emergency traffic more seamlessly. Next slide, please. And finally, this last option depicts a hybrid of the first two deployment models. In this hybrid model, the PSAPs may choose to share certain services while retaining other services on a dedicated on-premise manner. Obviously, there are many possible permutations of this option based on what services are determined to be shared or dedicated. And this slide simply shows one particular example. It should be recognized that the benefits of shared services will only apply to those services that are indeed shared and not to those that are not. I trust this gave some visibility into the benefits of a shared infrastructure service model. Thank you. Back to Jeff.
Thank you, Mario. So as jurisdictions and 911 authorities consider what optimization models and techniques best meet their needs, we believe that there are several key factors that should be kept in mind. Of course, a financial factor. What are the solution costs, both from a capital and an operational expense? Interoperability factors. How much, to what degree, do the PSAPs want to functionally interoperate and collaborate? Additionally, at what levels of interoperability does data sharing want to take place? Is it going to be local, county, multi-state, multi-county? And what degree of data sharing will take place? Survivability and reliability is another critical factor. What levels of redundancy and geodiversity are going to be required by the 911 jurisdiction? Elasticity and scalability, another factor. Meaning, to what degree should the system be designed to handle unanticipated peak loads? Additionally, to what degree should the system be designed to accommodate additional jurisdictions being brought onto the system without the need for re-architecting? Security, of course, is a critical factor. You're going to hear about that in Workgroup 1's report. Last but not least, as I mentioned in the very beginning, is staffing, often overlooked. Different operational and architectural optimization models require different levels of operational, administrative, and technical support staffing. Clearly, this is an important factor and must be taken into consideration. Chuck?
Thank you, Jeff. So in Section 5, we start the process of diving into the Esinet optimization consideration and factors. And as mentioned earlier, we separated this report into three primary areas, Esinet being the second one that you're going to hear today. The Esinet, or ESINet, as it's termed, is the managed IP network foundation upon which NextGen 911 solution is built. Today, most 911 stakeholders are familiar with the Esinet term and that it provides the secure managed IP transport infrastructure for NG 911 services. However, many still misunderstand the scope or role of the Esinet in that the Esinet provides the network connectivity. It does not include next generation 911 core services such as the emergency service routing proxy, emergency call routing functions, location information servers, etc. While the Esinet can deliver a 911 call to a PSAP, it can't route the call to the correct PSAP. From an Esinet evolution perspective, many elements required to implement a true end-to-end next-gen 911 service are not yet available or in place today. Therefore, the Esinets currently in use or being implemented today are primarily providing transport of transitional 911 services, such as IP selective routing and IP alley. As the transitional NG 911 architecture is more widely deployed, enabling the migration from legacy infrastructure to IP applications, services, and transport, the Esinet will evolve closer to the full NG 911 NENA I3 vision. However, for that to become fully realized, many more steps will be needed, such as originating service providers providing call or location data feeds to NG 911 service providers. The Esinet has four primary capabilities that are provided under it. Those are transport, which provides the physical medium to move IP packets within an Esinet and establish interface points with external entities. Second, Internet protocol services, including IP addressing and dynamic routing protocols, quality of service mechanisms must be implemented to ensure critical 911 services are not impacted by other services provided on the Esinet. And third, management infrastructure, which provides the overall framework for provisioning, monitoring, reporting, and maintaining the Esinet. Security infrastructure is the fourth critical category that the Esinet provides, which includes appliances and practices to secure, monitor, detect intrusions, and these, authenticate users, mitigate events, and recover. The Esinet provides a foundation of security capabilities to protect the Esinet itself and the services that reside upon the Esinet. In evaluating the different use cases, we determined that there, as part of the team, that there's no single definition or configuration that can be used to summarize all the possible Esinets, and that each different jurisdiction will have differing needs and requirements, and which should be taken into account. And one type of Esinet may be better in some cases than others. Several use cases are presented to define the configurations which are representative of the majority of the Esinet's uses and vision. These use cases define a framework definition for functionality that an Esinet is intended to provide, but is also instructive to define what an Esinet is not intended to provide as well. The first of those being the local Esinet, whereas the local authority elects to host next-generation 911 core services within the existing PSAP data centers or facilities and maintains their own Esinet. The second being the Shared Hosted Esinet, which is where a regional entity authority group, or such as a group of PSAPs, counties, multiple counties, or state, elect to host the next-generation 911 core services on a shared Esinet infrastructure. The third being a hybrid Esinet, which is where some elements of the shared hosted Esinet are combined with elements that are contracted. We expect this to be one of the more common types of configurations that we'll see, and you'll note that these are in line with the use cases that were described earlier by Jeff. The last one being the contracted managed Esinet. This is a shared network between multiple served PSAP tenants, which could scale from small regional to nationwide. The Esinet managed service vendor builds and maintains the Esinet for the users and customers of that service. Here we see a diagram of the hosted shared Esinet deployment models. This diagram illustrates the primary concepts of serving many PSAPs, originating service provider connections, and geographic data centers. Again, the Esinet does not include the NG911 applications and functions. It is the network transport, the IP services, management infrastructure, and security infrastructure upon which the next-gen 911 application and functions are deployed. Monitoring and operational metrics are critical to a well-functioning Esinet. 24/7 monitoring of the Esinet by a network operations center experienced and knowledgeable of both the IP network services and the next generation 911 Esinet operations is necessary to mitigate network issues expeditiously, preferably before they become service impacting. Network monitoring and management required of the Esinet with its extreme operational requirements is complex and resource intensive. It should also be understood that while critical to the delivery of 911 call traffic, the Esinet provides elements of the NG911 call flow. There are many other elements required to complete a call. These will typically include communication origination infrastructure, local access networks, and next-generation core services, where each and subcomponents of each may be provided by different independent entities. It's extremely important that clear lines of authority, responsibility, and process be established up front amongst all the next generation 911 stakeholders. Reliability is also obviously a key element of any 911 system or network, and Esinet is no exception to that. The Esinet must be designed from the beginning to be highly reliable and resilient. 5 nines is typically the Esinet availability goal. While rigorous, this can be achieved via design, engineering, and operational processes based on industry best practice, focused on diversity, redundancy, and resiliency. Now I'm going to hand off to Roger for coverage of the Section 6.
Thank you. As you've already heard, we broke out access from the operations or from the originating service environment into NG911, the NG911 core services piece itself, separately from the Sinet and the PSAP environment. Those are not arbitrary distinctions. The Sinet and the NG911 core services, for instance, are two separate functional things and have different characteristics and needs in terms of operations and management. One of the things that's characteristic of today's environment for access from the originating service environment, which encompasses carriers, OSPs, PBX operators, a growing case of app providers starting to act as if they're actually service providers, if you will, is that they all have certain responsibilities. The fundamental ones are connecting calls or multimedia, depending on how you look at it, into the NG911 systems and providing location for routing control. They also provide customer information in the case of wireline and VoIP type services. They, in today's world, typically do this via trunking networks that are either directly or indirectly oriented to individual 911 service systems. So let's take the worst case. Every county in the country, 3,200 of them, have their own 911 system. The carriers and other originating service providers have to find a way, either directly or indirectly through third-party vendors, to connect to every one of those systems. That's not really the way it works today, in that there are very few individual county systems. Almost all E911 systems are multi-county in nature in terms of how they're operated. They may appear to be serving a particular county from the perspective of the PSAPs and so on, but from an overall big picture perspective, they're multi-county in nature, with exceptions of Chicago and New York City and 2 or 3 other cases.
In those exceptions, is it correct to visualize their implementations as multiple centers? Are they more than one, or is it just one center for the largest?
In the case of Chicago and New York, they're a single PSAP, essentially, functionally. They have backups and so on, but from a standpoint of normal operations, they're a single center.
Can I?
Actually,
yeah.
This is Tim May. If there's going to be discussion as the presentation goes, it's critical that you identify yourself and then ask your question, because for the benefit of the people on the phone and for the captioning. Thank you.
So if I may, Jeff Whittick from Airbus. Roger is certainly on the mark. Chicago, New York, Philadelphia, for instance, their 911 systems serve that particular county. Answering your question more specifically, though, Admiral, New York is a single system. It's served by multiple DMS 100 selective routers, and they do have multiple PSAPs today that are served by those multiple routers, and in fact, they're building another. So at the end of the day, New York will be served by 2 very large PSAPs and a number of backup PSAPs as well. I think you'll probably find the same thing in a place like Chicago and Philadelphia.
Okay, thanks. And this is Dave Simpson. That's helpful. So we can think of those large centers in some respects as multi-jurisdictional themselves, in that they have distributed capability in more than one location.
Yeah, that's true. In the case of New York, the single system functionally serves all 5 boroughs, for instance. So they're sort of functionally separate jurisdictions, but they're all managed from a 911 service standpoint as a single geographic area. So it's a mixed mode to some degree. You could think of those cases as being really concentrated subsets of the more general 911 service process. And they're largely that way because of the size of the population that's involved with them.
I apologize, Roger. There's a couple emails coming in that those on the bridge, we really got to get that microphone close because the captioning is difficult. All right, thank you.
Okay, sure. I'll try to deal with that. So you can go back to the, okay. So as a result, the access environment today is pretty complex. One of the effects of NG911, depending on how it's deployed, is to simplify that access environment. And we'll talk here about 2 or 3 ways that can be done. We've talked about the PSAP environment. We've talked about the Sinet. We've talked about the whole structure of 911 service. 911 service technically extends from the caller initiating a call all the way through to the point where the PSAP has resolved what needs to be done with that circumstance. So in between, we have the common conception that NG911 implies routing a call based on the caller's location as provided out of the originating service environment and delivery to the PSAP. And in its simplest form, here's what it looks like. You've got the 911 call originated, you got the originating services environment, you have the routing function of the NG911 system, and delivery to an IP or NG911 capable PSAP. And that's done across a physical IP network, the Sinet. The Sinet and NG core services are not the same thing because it's a hierarchy. You have the transport network, you have the NG911 core services, functional processes that controls what happens on the network essentially with calls. You have databases that control the functional elements, and you've got people that control the databases. So it's a multi-part process, but what is often misunderstood is what the role of NG911 core services is in that picture. It's the center of the whole process that ties it all together and makes many of these functions possible. And in the case of NG911, adds new functions, as well as speed of delivery, improvement because of IP, and a lot of things that the typical observer doesn't recognize yet because it's not fully deployed. So, the NG911 core services piece is sort of the Rodney Dangerfield of 911 service. It doesn't get as much respect as the more familiar things like PSAPs and originating service providers and so on do. But it's really where the rubber meets the road in terms of making this whole thing work. So this is a very simplified diagram from the standpoint of what most people see as being how things operate. We'll get to a little more complexity later on. But first I want to talk about the access environment. In olden days, when you had central office switches that were localized and you had 911 systems that were pretty much localized in enhanced 911 terms, and the calls didn't originate from outside the territory and terminate someplace else, life was simpler, if you will. But in today's world, you could have an originating service environment that's nationwide or even worldwide that needs to access any given 911 system or PSAP based on where the caller is and where they're calling from. In the case of VoIP, for instance, you could have the control process for VoIP in Denmark, and the caller's in New York City and needs to go to the New York City PSAP. So it's all based on today's environment of very generalized and very expansive service origination and the need to get it to the right place. So we have to find a way to deal with that. And the way we do it is we provide routing controls either at national, state, possibly regional, and certainly within the given NG91 system itself that the originating service environment looks at and says, okay, I have a call here, doesn't matter where you are, it can be any place, in making this decision. I have a call here that's from a caller in Columbus, Ohio, and it needs to go to the Columbus, Ohio PSAP. So how do I find the access point for Columbus, Ohio? Well, we look at a thing called a forest guide, which today doesn't exist. So as a result, we're still doing all these individual connections and complexity of networking and so on. Look at a forest guide and say, how do I find Ohio? And it tells you where to go find Ohio. Then you go to the Ohio routing guide, and you tell it that you want to talk about Columbus, Ohio. Where do I find Columbus, Ohio? Well, that happens to exist in the regional NG91 system that covers central Ohio. So now we tell the originating service environment how to get to the front end of that NG91 system that concerns itself with Columbus, Ohio, and that NG91 system determines from the location information then where the exact address for the Columbus, Ohio PSAP is, and ships through a media setup, ships that call to that particular PSAP, along with the data, and then the PSAP has the ability to go acquire other information, including updates to location or additional data, via the NG91 system in the vision that we have of it. So in order to support that situation where we don't assume that the originating service environment necessarily knows who the PSAP or the 911 authority responsible for that PSAP is, or that responsible for that NG91 system, it's like I said, the legacy model of service area was very limited and local. In an IP-based world, the user could be in any PSAP and 911 authority's jurisdiction. So the intention here is to build a hierarchical set of data that says what I just described. How do I find lower and lower definitions to get to where I need to go from a PSAP standpoint? How do I validate the location information? How do I determine the appropriate public safety authority to receive the 911 caller message? And here we're talking about public safety authority being the responsible party for the NG91 service system, whether it's county-based, which in the long term is probably not the best way to go. It's a regional NG91 system, it's a state NG91 system, and so on. In terms of options for optimization, we have, for NG91 core services, we have a regional scenario, we have a state scenario, we have a multi-region or multi-state hosted scenario. Any of those can be applied, as was implied earlier. The NG91 core services process is designed to be so flexible that it can support any type of structure as defined by 911 authorities to get the job done that fits their environment and fits their economics and politics and operational needs and so on. So it's a very flexible process from that standpoint, but it does require some roll-up of data that allows the originating service environment parties to query and determine the responsible public safety authority, i.e. NG91 system, or but not the actual PSAP itself directly from the OSE standpoint. So the general forest guide concept is a tree structure where an OSE queries at the level of which they know the subscriber or user resides. If they only know that the subscriber is in Ohio or Pennsylvania, they can look at that information and determine how to go to that particular routing guide for Ohio or Pennsylvania, and using hierarchical location information can determine from that routing guide structure how to get it to the appropriate NG91 system and therefore to the appropriate PSAP. it requires cooperative sharing of GIS information, geographic polygons, that define the Public Safety Authority's service area. It's basically a situation where at the state level you need to know if there's more than one Engine 911 system. You need to know how many of them there are and what territories they cover. At the national level, you need to know where the state systems are, where the regional Engine 911 systems are when there's not a state relationship, and be able to look at the location and say, I'll work my way through that hierarchy till I find the right place. That all happens in milliseconds in terms of the technology involved. But the National Forest Guide doesn't need to know, I want to emphasize this, where every PSAP is or where every Engine 911 system is. It needs to know how to get to the next step in the process. And a state routing guide doesn't need to know where every PSAP is. It needs to know how to get to the appropriate Engine 911 system, which could be a state level system in the trivial example, and cause that call to be directed to the connection point for that system. So the bottom line here is that with those kinds of hierarchical data sets, you would no longer need to have every originating service party know exactly how to get to every Engine 911 system. Yeah. So it simplifies the access process in the long run. In the transitional environment we're in today, where some places have Engine 911, some places don't, some places have mixed systems, E911 and Engine 911, we're probably still largely stuck with the trunk-directed process as compared to the Forest Guide approach. But in the long run, the Forest Guide approach simplifies that situation quite a bit. Here's a diagram that says, okay, we're rolling up 3 counties into a state-level Forest Guide and rolling that up into a national-level Forest Guide so that everybody can look at that national Forest Guide and eventually work in such a way that simplifies their whole access process. Engine 911 in the long run, and we're moving toward that now, defines a different responsibility set for both the 911 service provider and the originating service environment. And the biggest changes evolve around the use of geographical information systems and that the originating service environment provides the caller's location, hopefully in very real time. That's not the condition we have today, and particularly in wireless. We have location information that is time delayed, and therefore the routing process is not as exact as it could be. Here's a little diagram of next generation 911 and core services in general. There's a number of functions in there. I won't go into them, obviously, but some of the let me look at something here real fast. There are many benefits to this system when implemented properly. I don't know that we have any document anywhere that really defines the benefits through the transitional process to the more in-state Engine 911 case. We need to build one. I've started an outline of one. I think people in the county commissioner's office and the governor's office and the people that make decisions about funding and so on need to have a better source for what those benefits are so that they can see why it's so essential that we get this done and done in a consistent manner across the country. So you'll see in the report some recommendations that suggest that certain things being equal, shall we say, economically and operationally, it makes more sense to implement Engine 911 core services on a larger geographic scale, regional or state level, is the typical case. There is many ways to skin the cat, and several of them are in use as transitional structures, but we're gradually converging on, I think, a single set of standards and a single approach to Engine 911. There's much more in the report about advantages and challenges and so on of the various levels of Engine 911 implementation, and I'll leave it to you to read those. So we'll move on at this point.
Lori's going to talk about governance. I'm going to kind of rush. We know we're pushing up against the edge of the envelope here, so we'll move forward quickly.
Okay. So, thank you. Clearly, there are a lot of decisions that need to be made with regard to technical aspects of implementing next generation 911, but at the end of the day, it's people will have to be making those decisions, and people will have to figure out the parameters and the processes that they will use to move these systems forward. And to the extent that they will do that together, they also have to figure out the parameters and the processes that they will use in order to work together. And clearly that's the governance piece. We thought in this section of the report, again, as Mary mentioned, there may be people reading this report who are not familiar with 911 or the history, and we thought it might be important for them to understand sort of how 911 grew up, if you will. It came from the bottom up. And, in the legacy system, it was not technically possible for PSAPs to be fully interconnected, and so they functioned independently. So we ended up with 6,000 independent operations in this country. And frankly, that has worked very well. And there are a number of examples of jurisdictions who have chosen to work together, and we've highlighted a few of those in the report. And that is, absent any mandate to do so and previous to Next Generation 911. But clearly, with the advent of Next Generation 911, it allows jurisdictions to share resources in a way that they never were able to do that before. And frankly, it raises the question of whether or not they should be sharing resources in a way that question has never been raised before. So the governance piece becomes important because the extent to which any jurisdictions choose to address resource sharing is dependent on their relationships. It's dependent on not only their willingness to share those resources, but also to share control and to share cost. And those are always very interesting topics to discuss, as we've already found out in this task force. But that will reproduce itself at the local and state level. So the governance issues become really important. Clearly, Next Generation supports a standardized model that supports and promotes resource sharing. And frankly, there are probably as many permutations of how to govern these systems as there are the technical permutations in terms of how it is carried forward. So moving forward, in terms of moving forward with the sharing process, again, the document is geared toward those who are in the positions that will have to make these decisions, whether they are the PSAP managers, the 911 authorities, their governing bodies, or all of the above. Those are the folks who ultimately will have to make these decisions whether or not to remain independent, to share resources, or some combination of those things. And frankly, they'll be responsible for the consequences of those decisions. So we tried to provide them as many tools as we could in making those decisions. Clearly, for not only technical but operational and administrative reasons, there's a lot of value in working together. And as I mentioned before, establishing the parameters and processes of their business relationships becomes extremely important. And the document in this section goes on to list ideas and examples and resources on a variety of topics, such as governance models, the need for supporting data, to measure progress in terms of establishing efficiencies, either technical efficiencies or operational or cost efficiencies, and making the business case for moving forward with Next Generation 911. So, in terms of making the business case, or what is the value proposition moving forward in terms of Next Generation 911, again, we tried to provide resources to the decision makers because they're the ones who are going to have to come up with the business case for Next Generation 911. They're the ones who are going to have to do the cost-benefit analysis and what I refer to as the denominator, conversation. So you've decided what might be best for your jurisdiction based not only on the technical factors, but all the things that you compare against those technical factors to make sure that they're the right decision for your jurisdiction, whether that's population or call volume or cost or any combination of those things. So we tried to find as many best practices as possible. There is a growing body of knowledge out there pulling from the jurisdictions that have implemented components of Next Generation 911, either the Sinet or some of the core services, and we provided examples and resources in the document. One idea that sort of came forward that may be of particular use is, particular models, including the value measuring methodology that the CIO Council produced, because it's a way of measuring. It's a way of doing a cost-benefit analysis, frankly, that monetizes things that are not normally included in the normal cost-benefit analysis, but they are things that are of great value to public safety. So we thought that was particularly useful. So in terms of the value proposition, clearly it includes a lot of things that are technical. All the things that are, in the center to the left on this diagram are clearly things that would have to be considered. But, this section talks a lot about the non-technical things that really also need to be considered moving forward, and whether or not they are workforce issues, system administration issues, operational issues, issues of governance and administration, financial issues, state and regulatory issues. And there are two things that I just want to mention quickly that the group adopted in terms of two assumptions moving forward with regard to, making the value proposition. The first assumption that we made was that the ultimate goal, the primary objective of this exercise for any jurisdiction would be in meeting the needs of the 911 callers to reach emergency help. And then the second assumption that we made, the second objective, the second goal, if you will, would be in providing the resources that are necessary for the telecommunicators to do their job. Steve has mentioned many times, the importance of those folks in terms of being the first of the first responders and making sure that they have the tools that they need in order to answer those calls and process them adequately. As Dave mentioned, in this document, we used the term 911 authority. I think in the past that has been analogous to a PSAP manager, if you will, or analogous to a PSAP. In this context, the 911 authority is really the responsible agency, the agency who's responsible for operating the 911 system. And in the context of next generation 911, it could be an individual jurisdiction, or it could be a collective. So it could be a state, county, or regional government that is responsible for operating the 911 system. And it runs the gamut. In the model, we don't prescribe. It could be a single 911 authority. There could be multiple 911 authorities. We spell out in the document clearly what, there are challenges and advantages to both. It's a good news, bad news thing, no matter what you choose to do. But certainly, in terms of the opinions of those who worked on this report, we had some recommendations, and I know Dave will go into those in the next section, but there are a couple that I just wanted to highlight because they became recurring themes for this group. The first one is that existing statutes and regulations really need to be reviewed because very often they do not enable the kind of coordination and collaboration that is required in order to move forward with next generation 911. So that's the first recommendation. The second clearly is a recommendation that jurisdictions are encouraged to adopt a collaborative approach. I mean, we have limited data in terms of the costs and the benefits. There are some startling examples of increased efficiency, whether those are operational or cost efficiencies. One thing we know for sure is that if everybody operates their own, that'll be the most expensive model. And funding being the challenge that it is, we are encouraging jurisdictions to adopt a collaborative approach. The third and the last recommendation that I'll just highlight is the need for uniform, consistent data. In order to measure progress and in order to provide the evidence of achievement of efficiencies, whether those are technical, operational, or cost efficiencies, it becomes really important to have a standardized, a consistent set of data to measure that progress. So those are the three recommendations that I would highlight. And I am going to turn back to Mr. Hall.
Thanks, Lori. Moving into the planning and transition considerations, which I think is one of the critical pieces here. It's an evolution. We've heard that discussed by various different sections, and at this point, we found no 911 authority that's attained a fully functional NG 911 implementation. But everyone's going to have to move from legacy through a transitional process into full deployment. It's largely going to look like this. So legacy 911 PSAPs into a transitional next-generation 911 environment, and then ultimately into next-gen 911. And there's going to be a variety of different ways that takes place with a variety of different configurations. So what would be the operating domains in doing that? Well, we have the OSE we talked about already, the NG911 core services that we talked about, and the PSAPs operating together to provide a complete 911 service model. So the OSEs deliver calls to the NG core services and then ultimately to the PSAPs. So a diagram of largely how that will occur. Again, it's things we've already kind of looked at, but the component pieces with that. Ultimately, 911 authorities need to make certain decisions. We've talked about that under the governance piece. In most cases, these governance decisions won't be made by the single authorities. They'll be made by a group of combined together authorities. So there'll be new coalitions, collaborations developed. And Tony can talk about some of the escalating costs.
Thank you, Dave. Tony Montani, Verizon. Wanted to cover a couple of key points. We've talked multiple times in these meetings about the cost of getting to Next-Gen 911. And the first thing that everybody thinks of is clearly the cost of the systems, the new first-time startup costs, making those decisions about where the data centers are going to be, making those decisions on the equipment deployment, making decisions on shared resources that'll help really share that cost. But the other component that is an inhibitor is the fact that you're going to be running dual networks over an extended period of time. There is no such thing as a flash cut of a 911 network. You can't do that. It's a life safety necessity that you take your time and you cut by component and you deal with your cutovers PSAP by PSAP. So what that introduces is a need for a transitional period to get from that traditional TDM architecture to get to that next-gen solution. But while you're doing in that transitional environment, you have multiple parties involved. You have the existing incumbent carriers that are doing the selective routing. You have existing databases and the need to maintain those records. And you have new carriers and new providers coming in that have the new next-gen functionality, but they have to maintain the databases. It all has to be done in sync, in unison, working together collaboratively to make it happen. But it's an expensive model. So as long as you're in this transition phase, you have operating costs that are going to be, in some cases, doubled up, and there's no way to avoid it. So what do? It comes down to a lot of things that we've talked about today, which is planning. If we go to the next slide. This just to give you a simple kind of visual on it. Really what you're starting with is maybe the top line of this. You see the legacy selective routers. You see the originating service providers that are connected into those legacy routers. And the first thing that's going to happen is you're going to have that next-gen cloud come into play. You're going to have that new Esinet. You're going to have that new service provider come in and start to introduce services. And they're going to start to migrate PSAPs onto that platform. The initial approach is always going to be, I think, connecting up to that existing legacy router. You repoint your traffic, and you start delivering those calls to the new provider, one PSAP at a time. Eventually, one thing that will start to create some efficiencies in this approach is you'll see the bottom scenario where those originating service providers are able to directly connect to that new provider. And that's another step in the evolution to get into an end-state model. But you'll start to see that migration, and it involves multiple companies, multiple entities. It's not just the originating carrier, the incumbent carrier. It's also the CLECs. It's the cable companies. It's the VoIP providers that can start migrating over to this new platform. So this model, I guess the main aspect of it is you're going to have PSAPs that are being served in the old and in the new, and you're going to have service providers that are going to be connected up through the traditional selective router and incumbent carrier, and eventually connected up through the new platforms. Go to the next page. So in terms of achieving this, again, an understanding of where you're going. What's the environment you're working in? The 911 ecosystem, I think, is the term Dave used a couple of times today. You really need to understand what is the end state of this network. I think it was Jeff earlier today, he mentioned that, when you build your network, you need to understand how many PSAPs, what's the size of this, so that you can add the organizations, add and grow out that network without having to stop and do box changes or do heavy lifting. It's got to be scalable. It's got to have an ability to continue that migration in an efficient way. Ultimately, this next chart depicts closer to an end state. What you see now is those selective routers. When all of those PSAPs have migrated to that new solution, now you can talk about getting rid of that selective router, getting rid of that legacy environment that's driving so much overhead onto the process. And this will start to become much more efficient. The last slide here just hits home the point. It's about planning. You don't want to study it forever, but you have to have a good vision going in as to what is it that this end state network is going to look like. Lay out that plan, lay out a timeline. There's going to be a big difference in cost to that local entity if it's a 2-year project or if it turns into a 4- and 5-year project. Everybody has to play. When the tide rises, all the boats have to go. So you have to bring all the PSAPs over to really effectively retire that legacy network, and that's going to be the goal for this effort in the transition. Back to Dave.
Thanks, Tony. So essentially what we're and you've heard it talked about, so I'm not going to dwell on a lot of these things, but we have three primary foundational elements to this process: the Esinets, the IP PSAP, and then the GIS data preparation, which becomes critical to the routing piece to this. They don't necessarily need to be accomplished simultaneously or any particular order, but they must be accomplished moving into a next-gen transitional plan. We won't get into the specifics of this, but essentially this is the public safety migration steps into next-gen 911 and all of the component pieces. This diagram is included in the report for everybody to take a look at, but it essentially encompasses all of those things. And at the bottom where it says today, months, years, many years, all of those things will depend upon the individual 911 authority and their plan and their movement forward in that transition. But essentially, there's these elements that are part of that. If the 911 authority does not have an Esinet, they're going to need to deploy an Esinet in some configuration. They're going to have GIS data associated with that for the routing. They're going to have security, which Jay will talk about later on in work group number 1. They will have to have the core or services element, and then they will have to have the applications. And all of these things will come together essentially to make a next-gen deployment. So what is the migration? They have to work with, as a 911 authority, to create that. In most cases, there is no established 911 authority. PSAPs should first address their organizational approach and how they're going to go about doing that, and then develop a plan moving forward. So real quickly to go over our summary findings, we have to say up front that this work was not exhaustive, that we look at this as foundational in a lot of ways, that additional guidance has to be developed to make best use of this information, and we encourage the FCC to charter such efforts as a part of their ongoing 2016 TFOPA initiative. There's a number of potential topics to be explored. Those things could be the potential costs of transition, the comparative early developer use cases, because there are a lot of early developers out there that have come a long way towards next gen, an additional study of access for people with speech and or hearing disabilities, and then also the integration of applications which provide access to the next gen 911 system to make full use of all of the smartphone application technologies. We're aware and had a lot of discussions about communications and communications technologies like the Internet of Things mentioned earlier, over-the-top apps, analytics, and other new networking technologies. And all of those things continue to rapidly evolve as this public safety ecosystem comes into play. As public safety technology ecosystem expands, all of these new technologies will have an important impact, and there will also be a lot of considerations moving forward with that. So as our report illustrates, the aspects of transitioning from the current legacy environment into the next-gen environment will have a whole myriad of technical, operational, political choices that governments, public safety communities at all levels will have to be involved in terms of the discussion moving forward. And those deployments will require increased coordination and partnerships. I think it was a common theme that you heard throughout today. So the overall goal of the report was to educate these 911 authorities and policy officials and the decision makers about the variety of different things, the components, the capabilities, the deployment options, the potential benefits, the things that they really need to be aware of moving forward as they develop an efficient system that's going to provide the same, greater service actually than what the existing 911 system provides, with a lot more capabilities. And these factors would include financial, political, governmental, and operational considerations. As Next-Gen 911 accelerates and matures, there's a variety of different things that will happen. There'll be a lot of impacts, a lot of choices, a lot of changes, and effective will happen with political and public safety agency leadership and the general public to manage those expectations. So moving forward and armed with that, these decision makers will be able to make the appropriate decisions for their own host jurisdictions used on a variety of different methods. And we note at the bottom it was not the intent of the working group to recommend, as you had seen, a particular configuration, nor the deployment of Next-Gen 911 for that deployment, but it's a report that's absent one of those one-size-fits-all, because we think that there's a lot of different configuration options. All of those configuration options will utilize the core elements that have to be included no matter what the configuration is in a next-gen deployment. So primary message, again, talks about customization, configuration based upon the common elements. And it's important to take a look at the findings and considerations that we have, that we represent in an outline of the highlights over 29 of those considerations. And those considerations largely fall into a number of categories, 7 of them in policy regulation, 7 of them in governance, 6 of them in architectural, technical, 6 of them in standard best practices, and 3 in education training. And just to hit some of the highlights with those, the first is effective communications and coordination among political leaders has to take place. Public safety leadership and the general public is going to be absolutely essential. Another under the governance area, the national system of collecting data and analysis, we found that there was a disparate manner and there's no common system for what that is, and that needs to be also developed. Also further enhancements to the governance regulation of 911 systems, the advisory committee comprising of major groups from across the country. New governance structures designed to optimize potential benefits have to be addressed as well. Next-gen core services are going to be, as we mentioned, I think critical. And we recommend 911 authorities explore the use of shared infrastructure systems and models. Under architectural technical, we talk about PSAP managers and other 911 authority leaders starting to familiarize themselves because this is a new model. It's a new paradigm. It's a new age. It's new concepts. A lot of times what we find is people still think in terms of legacy technology with a legacy mindset. And this will take a whole new vision of what that is based upon the things we've talked about today. Jurisdictions and authorities have to analyze and consider a whole bunch of factors, among them financial interoperability, survivability, reliability, elasticity, scalability, security, operational staffing, and service operations effectiveness. Those responsible for Next-Gen 911 systems should be looking for ways to drive network interconnection across their jurisdictions, and they have to be looking at what are the optimal configurations, not just for their own system, but when we talk about a system of systems, they have to talk about how can they link to those other systems and how can those interoperabilities take place. We recommend also that the Sinet, the Next-Gen core services functions, and the controlling databases be monitored, as you had heard earlier, by a network operations center 24/7, 365. In terms of looking at standard best practices, the integration and transition of end user applications into the Next-Gen 911 system needs to be developed and needs to be studied further. And what are the implications of that? So an industry group is recommended to study those implications and those user applications that currently cannot access 911 directly. We think education is going to be a critical factor moving forward here as well, not only of the 911 authorities and those decision makers, but also of the public to understand what the capabilities are and what the limitations are moving forward into a next-gen world. So comprehensive outreach and education has to take place at all levels of government. So in concluding, the infrastructure that provides 911 is undergoing a rapid change, a major change, a paradigm shift of sorts, and legacy 911 is inadequate to meet many of the consumer communication expectations that we have utilizing our smartphones. And as a result of that, all of these changes in a next-gen world will have to take place. And the degree to which these decisions are made moving forward will determine how fast this process is accelerated or how long it may take. There's still a tremendous amount of work to do. We know what the basic elements are. It's a matter of pulling all of those elements together and developing to some extent, and then having jurisdictions, however they are devised, working together in order to promote that and move that forward. So with that, we would thank you for your indulgence in our prolonged report here this afternoon. And we would have any questions and turn it back over to Steve and to...
If there is anyone with a question, either on the bridge or in the room, please remember to identify yourself and speak into the mic.
This is Brian Fonce of NENA. I don't have a question. I just wanted to underscore one point you made. Just at the very beginning of the report, you talk around 34% or higher of U.S. households that are wireless only. The Center for Disease Control just issued within the last 10 days an update of that report. So it's now close to 50%, which, in my opinion, underscores all the more the points made in your report.
Anyone else? To Jay, first and foremost, thank you for an extraordinary report. And for all of those that assisted you, our national treasure here at the end, Roger, thank you, Roger. Jeff, Mr. Vic, Tony, Mary, Lori, Dave, of course, and Mario, thank you so much. Since all of us worked in the PSAP, we all know what the term is when a supervisor shouts out in the middle of a pursuit or a line of thunderstorms that brakes are suspended. This brake is suspended. Brake on your own, you know what I mean. So if you have to leave, get up and leave, because we still have a lot of work to do. But before I turn it over to the Admiral, I want to thank particularly Jeff as well as Lori for mentioning that thing which we mentioned on day one when we met here. And we had no idea back then in January of this year what this report would look like, but we knew it would be highly technical. But we also knew that even though it was highly technical, that it was absolutely imperative that we give appropriate time and attention to those people in a darkened room sitting before 6 monitors at 3 o'clock in the morning that are our call takers, the gateway to 911. So thank you both for mentioning that. David?
Yeah, thank you. We talked near the end there, Dave, about the length of the transition and multiple impacts and how important planning is for that. I think we also need to remember that there's an element that isn't completely in the control of the PSAPs or the 911 authorities, and that's the reliability and the affordability of sustained operation of the legacy carrier infrastructure supporting that. And there'll be an aspect of this for the late transitioners where that need to jump into next gen becomes not something that they can no longer plan for. The increase in failure of legacy technology that's no longer being supported with the supply chain, no longer generating any investment capital, takes the luxury of planning away from them, and they'll be reactive and drive up costs and increase risk for those communities. It also strikes me that, Jeff, as you described the models going forward, that there's a model that wasn't exactly described, but I see where proactive planning isn't being done. There is work that I call leaning out legacy, and where PSAPs are making marginal improvements enabled by IP just within a single PSAP. Their service providers are also leaning out their operations, and in some cases that leaning out is just oriented around lowering costs. And that also creates a significant risk factor that we all saw in the sunny day outages, where we leaned out too much and had IP-enabled functions that used to be done in a jurisdiction now done nationally. So I think we need to be mindful that that kind of default situation is we'll see a leaning out of legacy, and that we ought to have risk equated with that and understand that has very significant risk. Mario, I loved how you described the opportunity for collaboration between PSAPs, and there's not a PSAP that I visited that doesn't have mutual aid agreements with adjacent PSAPs or other entities. It also strikes me that with Next Generation 911 and the ability now to have IP-enabled applications that really help supercharge collaboration, that there'll be increased collaboration within a jurisdiction as well with the dispatchable assets, so that the 911 operation centers will have more of a collaborative set of capabilities with the police department and with the fire and even with EMS en route. Would you agree that we'll see more collaboration in that area as well?
Yeah. No, I think those kinds of capabilities are really built into the IP fabric. And I think it's very important that, it be nurtured, because I think what you're seeing happening in cloud technologies and the internet and the rapid evolution of features and capabilities, that should be brought into the PSAP as well.
Yeah. Thank you. Jeff and Chuck, as you described the model of PSAP options and brought in the benefit from off-premise cloud-based platform capabilities that are then providing capabilities within a PSAP. I didn't see it, but it does strike me that you very much want to make sure that in your contingency plan you've made up for the fact that you don't necessarily have every function 100% supportable within the PSAP, by ensuring that you've got multiple lines of diverse communication paths to get to where those platform services are being provided. And while the stat of 50% of homes now served by wireless is important for homes, I think it's also important for PSAPs that we look at broadband wireless as one of those alternate paths that is usefully diverse in architecting for PSAPs consuming capabilities outside the brick walls. Do I have that about right? Or what?
Yeah, absolutely. That's correct. And I think you're right on the mark there with respect to wireless as well as being a key alternate path, going forward into the future. In that, in most cases, or in many cases, it's the last mile that ends up being to the PSAP that ends up being, the weak link or the piece that gets cut, and that through the design, as we mentioned, of having alternate options to route the call to an alternate site, or as you're indicating there, an alternate transport method, non-terrestrial, then that would also help to address that issue.
Before we scoop up all the dollars and recover those savings, let's pay for the alternate comm paths. Yeah. It also, you had the notion of supported PSAPs, and I love how you displayed that. It also reminded me of what I saw very recently in Pittsburgh, in Allegheny County, where the notion of PSAPs is evolving as well, where we have PSAPs that are temporal, that are stood up for a special event, and then stood down at the end of that event. So in the case of Pittsburgh, when the Steelers win because Roethlisberger is playing, they've put a mobile PSAP in the parking lot, and 911 calls made within the stadium are in fact better served by an on-scene PSAP there. You can just, I think, imagine in the largely attended public gatherings as we go forward the value in being able to create more innovative PSAP relationships that I think is implicitly supported by what you've laid out here. Jeff, is that about right?
Absolutely, Admiral. I think the ability, one of the major advantages of that IP environment, the NG911 IP environment, is to be able to dynamically handle changes in the network and in the PSAP operation like that.
Yeah. And that flows well into the next question I have with regard to metrics. And the discussion seemed to be primarily oriented around metrics within the PSAP driving decisions, but that it seems to me that metrics in that shared population in either the hybrid or the shared model are also very important and need to be commonly understood and monitored outside an individual PSAP so that the threshold for it cuts over, goes to the other PSAP is automated, at least in some respect, and that even beyond the notion of the shared PSAP or the hybrid PSAP, where you have boundaries that drive more manual mutual aid agreements, that you'd want a semi-auto relationship now enabled by a fully realized next-gen 911 capability.
Completely agree again, Admiral. Going back to one of the things that Lori said, as we create these new 911 authorities and implement these governance structures, the monitoring of the data and even down to the automated level as you describe, we think that should be included in the governance, in the agreements that are signed. That should all be taken care of up front during the planning.
Great, thanks. Roger, in the description of forest guides, and it's really important that we be able to reconcile ESINet addresses with where the calls come from, which won't, as you laid out well, always be in the same regional area. You described the hierarchical model and stated that not all the information regarding the local forest guides needed to be in the National Forest Guide, and it'd be a devolution of functionality. But it does strike me that that there's an alternative model, and that would be a distributed peer model. And when we look at what we're doing with local number portability, there's more of the sense of there'll be peer representations of the database that are regionally oriented, but can all back each other up and are all fully functional. Is that something that should or could be looked at as we go forward and determine responsibility for maintaining forest guides?
Well, the overall structure of the forest guide process already includes some of that, in that you have multiple places to go to find the next address, if you will, that you're trying to get to. It's not a single channel process. That could probably be expanded, I suppose, to some degree in how it's currently designed.
Yeah, it just seemed to me that in the hierarchical representation that you had, that we're potentially overbuilding forest guides in a way that might actually be counter to the resiliency and availability of that capability, and presents significantly increased attack surface. If I were a cyber attacker, I love seams. And the more that you get in that devolution, yet still have strong trust relationships, that it just may be useful to look at 6 regions across the country or some number that would allow for fewer of those seams, but still have the right degree of robustness and resiliency. 4 ways to get to at least one of the forest guides that can support all the others.
Yeah, it's a balance of minimal data to get the job done and duplication and resiliency when it comes to that aspect of it. And certification is already also part of that. Right. And that anybody that's going to come into that system, it's not a wide open arrangement that says, oh, I started an internet process today, so I'm going to start sending calls without anybody knowing they're arriving, through this process. They have to be certificated, essentially.
Yeah.
From that standpoint.
And not just certified from a policy standpoint, but identity certification, access management. Yeah.
I can,
Great.
yes.
Yeah, thank you.
Exactly.
Yeah.
Right.
And last area, governance. Laurie, thank you so much for taking a really tough topic on. Governance, who decides, who pays, who does, and you described very well, I think, how that will naturally have to evolve under next generation 911 as we look at the things that lend themselves to the economy of scale. It strikes me that there's a hybrid governance piece that should be described as well, though, because if we look at the hybrid technical architectures, there will be aspects of next generation 911 operations for which the who decides about the sustainment of an Esinet might be statewide. But within that same state, the who decides about workforce might still be retained at the local level, and then the who decides about workforce training might actually be a regional effort of a couple of counties getting together. I thought that was implied in your brief, but that's part of what best practices need to, in fact, tease out and not leave that who decides, who does, who pays to chance.
Clearly there are as many interpretations to the governance as there are to the technical piece in terms of exactly what and exactly who and exactly how. You're right. You're absolutely right. Yeah.
Great. Yeah, thank you. And just from the quick scan I did of the written report, you examine those seams well and start to point out so that decision makers are at least know the areas where they need to be answering those 3 questions. Yeah. Okay. Yeah. Excellent report for the whole team. This is really helpful. I think it's helpful for the FCC in understanding our limited role in this, a facilitation role that we can play, but I think it'll be a phenomenal resource for local and state decision makers. Thank you.
One thing I might add is in the Esinet piece, we talked about 5 nines for the Esinet. Yeah. But I really think that the 5 nines has to apply to every point of the entire 911 system, ecosystem. So when you're talking about core services, I mean, there should be the reliability, redundancy built into core services. That at every level of this operation, the same thing. So that, a caller is pretty much guaranteed, or whatever the data source is that's trying to get into the 911 center through the system, that they know that there are alternate paths and alternate routes, and the 5 nines concept should really be applied at all points of the system, not just the Esinet.
Yeah, that's a great point, Dave. If you just have your objective 5 nines for the Esinet, but then you've got 5 nines for the CAD, and then 5 nines for the forest guide, and then it doesn't take too long to get a couple of 5 nines, and you're at 3 nines, and then you're talking days of outages tolerated over a year, and that's not going to cut it. It's got to be 5 nines of end-to-end delivered capability. Thank you.
Let me add one comment, if I could. In a few weeks, I will have been involved in 9/1 for 30 years. So I suppose that might qualify as a national treasure. I don't know, national treasure. But during part of that period, I was a 9/1 system service provider, and we spent a lot of our time making the whole overall process, not just the network, not just the software, not just the databases, but the human procedures as well, as reliable as we could possibly make them. And in 9/1 service, you have to assume that you need to deal with the conditions when it doesn't work right. You've got to have a design and backup procedures and operations procedures to do that. And, in regard to that, as well as the governance process over the last 30 years, it would be my opinion that those parties or those groups, whether it's a state or a region or whatever, that have had a good structured pre-planned governance approach have gotten things done faster and more effectively than those who do it on a semi-random planning basis, on a localized basis. Nothing wrong with localized management. The functions that need to be local need to be managed locally, but the functions that are core to the overall process, whether it be network or engine and core services and so on, need to be managed in a way that allows them to be operationally consistent and to have the same approaches and concepts applied to them. And that typically means something other than the local PSAP. It's not that local PSAPs are not competent. They are for what they're best applied to do. But when it comes to engine and core services, it just like an enhanced 9/1, it's not reasonable to expect the same results if you're doing it on a very localized, disconnected basis as compared to a more common managed approach. That's been my experience over that period of time. So those states that have had governance already set up have gotten engine 9/1, just even in a transitional sense, done more effectively and more quickly than those who haven't. So if you're starting from ground zero, and unfortunately the state I live in has started from ground zero, and they now have a state 9/1 administrator, and they're starting to coordinate some things without overwhelming or insulting the local control aspect. You got to know where to pick and choose and what needs to be done best at what level. And when you get to that point, you're on your way to moving this forward more rapidly.
So more planning pays for itself. More planning at multiple echelons, given the nature of economies of scale in Next Generation 911, pays even more.
Yes,
and creates
exactly
operational value in the ability to be agile in response to changes, both in attacks, threat vectors, but also changes in new functions that can be rolled in because you've got that planning nested at various echelons, as well as then the ability to monitor the failure rates and the 5 nines that are just the Esinet, and to see that, whoa, in CAD we started to dip below that, whoa, if you've got your planning between your echelons coordinated, then you can be much more responsive to that observed change in results. So, Roger, couldn't agree with you more, and I think that's an important concept that we ensure that the final report.
It's a hard one to implement, obviously.
Oh, it's yeah.
But it's fundamental to getting the job done in a more efficient way, I think.
Sure. Thank you.
Any other questions before we move on? Yes, Brad.
Thank you, Mr. Chairman. I have a kind of a comment and a question at the same time. So one of the things that I look at this from, wireless service provider standpoint, or from the interface from the PSAP to the carrier, was we look at advanced services and how we're going to leverage the ability for these PSAPs or these carriers to make the most of the new service offerings. I want to make sure that we're able to help the PSAPs during their decision-making process leverage the examples that were given earlier about sensors on a bridge and how those sensors are going to be able to interact into the PSAP. And, it's simple. It's easy to say it's going to be an IP network and there's going to be APIs and that's how it's going to work. But practically speaking, that's not how it really happens, right? The APIs have to get programmed. they have to get programmed by somebody who's going to be that equipment manufacturer, and that equipment manufacturer's going to charge for that, or they're going to have a different set of APIs for their box versus the guy who's doing their box. And location technology, when you get into next gen location, there's going to be a whole different world of things that are going to be happening with those services. And so, I'm not sure that there's, again, it's a comment more than a question about how do we ensure that application layer of services gets the appropriate amount of attention in the report that says I think there's really an opportunity where there's some guidelines that could be put forward or included that says here's a baseline of APIs, suite of services. Here's some services that need to be included or enabled as part of any equipment manufacturer, anything that's hanging off of the Esinet into the PSAP or offering services to allow for these guys to make sure they're future-proof, because we know these services are coming. The last thing we want to do is put them in a position to be already a step behind services we know they're coming, not to mention things we don't even know they're coming. So that's kind of what I want to mention.
Brett, I'm hearing two things in that. One is that the better job that the Next Generation 911 community can do in defining the interface with Next Generation 911, that will give innovation and the venture capital confidence in the, wow, I know what that connection's going to be, so I'll go ahead and build the sensors for the bridge that I can then reasonably understand how that would scale up as a business to sell bridge sensors that in fact communicate to PSAPs. But the second piece is that there may not be a natural market for public safety IoT, public safety Internet of Things, that we would potentially, in defining that category, then give an aim point for S&T and R&D investment efforts that as DHS, S&T, and other kinds of government efforts to kickstart public safety capabilities, that there'll be a focal point now to get some of that going where a natural market doesn't exist for those public safety IoT devices to come to fruition.
Yeah, I mean, this is, listening earlier to the proposed analytics position around the PSAP post and that whole, I mean, it opened up a world of thought process in my mind around what you're going to do to build that and how that's going to happen, because you have to pull from so many different systems, and that's going to happen in the commercial world. So there's going to be sensors that you can put on a bridge to measure the bridge's stability. Now, how do you take that information? That information will be available. How do you take that out and then put it in some meaningful way that a PSAP is going to be alerted at some threshold that says there's a problem?
Yeah, it's really hard. I think it goes to governance too, because the people that would pay for sensors on bridges aren't necessarily the people who would pay for an analytical piece of that in a PSAP. So I think it's a great point and one worthy of the task force to look at how that might be treated in the final product.
Right, and I just brought up because I don't know if it's appropriate for this part of the report, or it's not necessarily the security part of it, but it's kind of security. It's kind of here. It's but when you talk about these application layers, I think we're doing a disservice if we don't be as thoughtful about future-proofing this or giving the PSAPs the opportunity. Because if you look at I have a bunch of small operators and they buy a billing system as an example, and then we call them up and say, how about this new service, and they call their billing provider and they go, oh, it's $100,000. They go to put some APIs in, it's $100,000 or something. The last thing we want to do is put a burden on them to deploy a new service that's going to have to change a bunch of these things that they say, we just deployed a billing system, or we just deployed this new system, now I got to pay something more to offer this additional system. The more we can be thoughtful about that, I think the better we're off. And future-proof's a silly word, but it's the only one I got right now. Thank you.
Thank you. The next order of business is for us to vote to procedurally adopt and accept this Work Group 2 report. You might remember, looking back to our September meeting, we did that with Work Group 3. And we'll do it with work group 2 now, and then following with Jay English is in work group number 1. By a show of hands, can I see all that vote to accept? And to those on the bridge, simply because it might be an easier way to do it, does anybody object to accepting work group 2 report? Hearing none, we will accept procedurally the effort of work group 2, and Jay, and to David, and to everyone. Thank you so much. Breaks are still suspended. Jay, we turn it over to you. By a show of hands, I see all that vote to accept.
Thank you. Jay English, until today, chair of Working Group 1. We'll see how it goes. I'd like to thank the Commission and the Bureau for the opportunity on behalf of Working Group 1 to have completed this work. In addition, I'd like to personally thank all the members of the working group who gave of their time and participated, but there are 7 individuals in particular that I'd like to name because they went above and beyond the call of duty, attending additional meetings, spending extra time, including weekends and holidays. I think that deserves recognition. Drew Moran, who couldn't be with us today, Mary Boyd, Bob Brown, Anthony Montani, Heath McGinnis, April Heinze, and Gina Green were all instrumental in the final report. In addition, Dave Hull, Working Group 2 chair, was a collaborative and cooperative partner with everything that was done in Working Group 1, and it is greatly appreciated, Dave. Also, there are 2 folks on the Public Safety and Homeland Security Bureau staff who put up with me as the chair and a lot of issues with the working group for 11 months, Tim May and Dana Zellman. And, sir, I'd like to make note of the fact that they were very supportive and steadfast in their support throughout this process, and that, too, was appreciated by the working group. See if we can start. There we go. I am not going to discuss all of the details, and I do not have 85 slides. By necessity, I will be brief, and we will get this vote done probably in the next 30 minutes. What I am going to do is discuss the high-level outline of the report and the intent of the working group and some of the specifics as to the recommendations, and hopefully the committee has read the 75-page report to make an informed decision, and we encourage public safety at all levels to then use this report as a resource. As Dave mentioned, our report is not intended to be definitive. In the cybersecurity world, we could come up with a report today that said these are the 101 steps you need to take to defend your enterprise, and then tomorrow we'd have to change them all. Because as we come up with methods to defend our enterprise, criminals and nation states are coming up with ways to thwart those methods almost as quickly as we can come up with the ways to stop them. This is a living document, and cybersecurity is an ever-evolving process. Keeping that in mind, we intended to and believe we have delivered a foundational document, something that future iterations of TFOPA can build on, and something that public safety, we hope, can use. The report outline is broken into the initial objective scope and methodology, 3 sections on cybersecurity as it exists today and some existing best practices, and the architecture options for the next generation of 911. In addition, and we think these are very important, there are 3 appendices, and we'll discuss what those are and why those are tools that can be used by public safety today. The objective was fairly high level. We wanted to address issues of increasing exposure to cyber threats in the public safety emergency communications realm. We limited our scope to the identification of those issues and to documentation of recommendations as they relate to public safety answering points with the following qualification. A local PSAP, as Dave mentioned, is more than a standalone entity. It is part of a larger ecosystem. It is part of that entire emergency communications enterprise, which includes 911 authorities at multiple regions and may in many cases include primary and secondary PSAPs for call taking and dispatch centers which interface with them, all of which will be part of ESInets and of the emergency communications landscape from the cybersecurity perspective, they must all be defended. We cannot defend in a silo, nor can we defend 6,500 different times or different ways. Our methodology, we believe, was fairly well grounded. The reduction of any cybersecurity framework to practice, as stated in the slide, really is rooted in the ability to identify the assets involved, identify the owners of those assets, and then determine what the threats are and the risks associated with those assets are. We've tried to do that in this report at a high level. In addition, we use the current architecture as a starting point, moved into the transitional architectures as defined by Working Group 2, and then moved into a true next-gen architecture and made some recommendations. We used use cases to illustrate to public safety just how critical cybersecurity is right now today. And without going into detail on those, we will discuss the 4 use cases, but we believe that those use cases could be used by cybersecurity or by public safety today to start coming up with a defensive plan that would impact them not only in the current environment but in the transitional and next-gen environments. Section 1 talks about cybersecurity as it exists today. We begin with a discussion of the Information Security Management System, ISMS, and the overarching view that currently takes. That includes documented policies and procedures, compliance steps, and general awareness. As Group 2 stated, awareness, education, and outreach are critical. If you ask the average PSAP director, and we vetted this by talking to PSAP directors who were in our working group as well as outside of it, what their cybersecurity plan is, the majority of them would refer you to their IT folks. That is, those who have IT folks. The rest would say we do the best we can, or we have no internet access. Because right now there is not a thorough and in-depth understanding of cybersecurity practice or the frameworks, and that is simply because PSAPs are busy doing what they do every day, and this has not needed to be on the radar. As we transition into a new environment that is all IP-based, it most certainly changes how we have to approach cybersecurity and defending our enterprise. We talk about access control, and that is not just physical access control, which we are good at. That is network access control and enterprise-level access control. It includes elements of physical and logical security, but it also necessarily includes the human resources aspect, ICAM being one part of that in the vetting process of employees, but policy and procedure and governance become a very important part of how we administer cybersecurity. A lot of other security controls are discussed, including continuity plans, disaster recovery plans, and how we internally monitor our networks for security today, and network entry point security elements. Again, this is in the context of what we do today and some of the best practices that we can recommend. Section 2 talks about specific best practices that exist as the result of work from entities at primarily the federal level. The reason that this discussion is so important, it is not an attempt to say from federal down to state and local, thou shalt follow these policies. It is simply an exhibit of existing, logical, sensible, working frameworks that public safety can use to make informed decisions as they move forward on their own independent cybersecurity plans. We discussed the NIST cybersecurity framework, ICAM from a federal level, DHS recommendations and resources, the NICE workforce framework, and CISRIC best practices. For NIST and NICE, we relied heavily on work that was already done by the folks over at NIST on their cybersecurity framework. However, what we attempted to do was take that NIST framework and boil it down into areas that are not only understandable but implementable to public safety. And this applies from the local PSAP up through potential regional, sub-state, and state-level enterprises. The idea being that there are occupational specialties and functions within a PSAP that are specific to a PSAP. There are cyber physical systems within PSAPs and 911 authorities and at the sub-state and state level, whether you choose to implement any of the 3 Working Group 2 recommended architectures that all need to be defended. And in defending those, it is important to consider the NIST framework and the 5 basic tenets of that framework. It's also important to consider at what level each of those could or should be implemented. One of the biggest challenges that I think we had was understanding that the average PSAP in this country, well over 70% of them, are 3 positions or less. They do not have cybersecurity specialists, nor will they, nor should they. They don't have the funding or expertise, and they shouldn't be expected to. The NIST framework is just that. The recommendations that this group made and the charts that we've come up with, which I've done you the mercy of not sharing with you here, simply attempt to identify to PSAPs and 911 authorities those areas where they may be able to take action and those areas where they need to consider that it must be done, but not necessarily by them locally. We then move that into the larger enterprise approach and talk about some of the options that they may have moving into a next-gen environment to share some of these capabilities, much as they'll share some of the core services in a next-gen 911 architecture. The NICE framework, which is the workforce side of the house, also from NIST, is particularly important. And that is because you are only as strong as your weakest link. In the case of the PSAP, our strongest asset is our people. And unfortunately, our weakest link when it comes to cybersecurity is our people. It is not because of a desire not to do the right thing. It is because of a lack of education as far as cybersecurity and cyber hygiene are concerned. It is also because, until this report, we really haven't delved into the problem and gone to the level of what exists in a PSAP that is different from a corporation, and how do we handle those different positions within the PSAP, and what do we recommend based on the very good work done in the NICE framework that PSAP should implement. We have a number of pages of spreadsheet that take the NICE framework and map it to specific occupational specialties within the PSAP. Additionally, thanks primarily to the operations folks on our working group, we've come up with some additional occupational specialties that are unique to the PSAP and then mapped those to the identified training in the NICE framework. We believe this provides actionable information for the PSAPs, and we believe it provides a useful tool out of the box that they could open and use today. And in that respect, it is probably one of the most important things that we've included in the report. The next section deals with the Department of Homeland Security recommendations. The reason that we have used that is because DHS and several divisions within DHS have been actively engaged in cybersecurity and cyber defense for some time. We did not attempt to reinvent the wheel. What we did attempt to do was take advantage of the good work done there, and courtesy of Dusty Rhodes from DHS OEC and his cohorts over there, we got some very good information on what DHS is doing. In addition to the bullets identified on this screen, you will find that later in the report we have integrated much of what DHS and FCC are already doing into our recommended future approach. The General Services Administration came up with the Identity, Credentialing, and Access Management model that we used in this report, the FICAM model, the federal version of that. In addition, we referenced NIST Special Publication 800-63-2. I will not read more numbers, I promise. And we discussed the roadmap and implementation guide. The reference to ICAM in this document is not intended, and we specifically state this, to tell state or local or tribal or territorial authorities what they should do with reference to ICAM. Instead, again, it is a high-level education and, for lack of a better word, familiarization exercise so that folks understand what ICAM is. We're very good at vetting individuals when we hire them. And we do background checks, and we fingerprint our folks, and we know who the individuals walking through the door of our PSAP are, and if we don't, shame on us. But we don't take that to the next step and take that, in many cases, and take that individual who has been verified and vetted and checked and move into any kind of multi-factor authentication process for allowing them on our networks. What we do is we say, here's your username and password for CAD, and here's your username and password for 911. And here's your username and password for the radio console. And by the way, don't share that, but everybody shares that. So a lot of times you'll walk into a PSAP, and the person who was logged on at 0700 yesterday is still logged on. Or someone logs on as their training officer. Or someone forgot their password, so they use someone else's. It happens all the time. And in today's environment, it's not only forgivable, but it's not catastrophic. In tomorrow's environment, when we move to an all-IP infrastructure, it could potentially be very catastrophic. And we would have no way to trace back to the individual responsible. In addition, we would have no verification on more than one level that the right person had access to the right systems at the right time. As we have seen in events of late, forensic evidence is very important. The ability to backtrack a criminal or nation-state actor makes the difference between an investigation that is successful and thwarting future attacks, or an investigation that is not successful and future attacks succeeding. ICAM is an incredibly important part of that overall process. Our intent here in introducing it is simply to allow for local, state, and regional authorities to understand what it is and why it is important, and to start thinking about it and begin plans for implementing ICAM. Our recommendation is that future work be done on this, along with several of the other areas that we've made initial recommendations on. I'll be brief on CISRIC. We reference it. We think it was good work. We do not rewrite it. We provide a link and allow folks to go read it themselves. How's that for cutting one slide into 10 seconds? And now some of the areas that are near and dear to many of us who were on this working group are, how are we going to handle the future? The threat to PSAPs, emergency communications centers, and public safety is undeniably real. Cybersecurity exists because cyber attacks exist. TDOS and DDoS attacks occur today on a regular basis. Last year alone, well over 300 documented TDoS attacks specifically targeting public safety. DDoS, which is a distributed denial of service attack, are on the rise. These are happening in a legacy environment. The threat is very real. Both criminal elements as well as nation-state actors have been verified as being involved in these attacks. The threat will increase exponentially when we transition to IP networks. As with any other good deed, no good deed goes unpunished. We will transition to IP and we will face new threats. If you have a computer at home and you are connected to the internet, every threat that you have on that system becomes a very real threat to a PSAP who has an IP system. That's probably the easiest way to summarize how dangerous this can be. In order to address the threat, and I briefly hinted at this earlier, we have to think outside the box. The criminals are faster, more agile, and in some cases better than we are, but that does not have to be the case. They will change vectors. They will change actors. We must be able to adapt to that on the fly. Much as cybersecurity investigators do today, we have to be able to anticipate their next move and be able to, if not block it, at least immediately intercept it and take action. To that end, the working group is proposing a new element known as the Emergency Communications Cybersecurity Center, EC3 or EC cubed, whichever you choose. It is an integrated intrusion detection and prevention system. It works complementary to things like the Network Operations Center It could very well be co-located with network operations centers. It could be part of fusion center models. We do not make a specific recommendation as to where to physically locate the EC3. What we do make are some recommendations around the need to start using information sharing in real time across enterprise immediately. Personally identifiable information always gets people's attention. We cannot share that under our system of laws without good reason. In the EC3 architecture concept, we propose consideration of the deployment of a number of types of sensors in concert with federal, state, local, tribal, and territorial partners that do not include PII, specifically in order to get around the privacy and security concerns. Additionally, the deployment of these EC3s at whatever level needs to be a cooperative and collaborative endeavor. Having run several PSAPs and been a responder for years, I'm well familiar with the siloed or kingdom or fiefdom approach, and we all know that's a political reality. In order to properly construct, implement, and operate an effective cybersecurity system, we have to think differently. Much as we will have to think differently with the next generation 911 architectures, we need to sit down at the table and have the hard discussions about governance, and about sharing of resources, and about cost, and about the most effective way to defend an enterprise. When we started this 11 months ago, gosh, it seems like 11 years, Admiral Simpson mentioned something very important, and I'd like to go back to that briefly. The Department of Defense employs thousands of personnel and has millions upon millions of dollars to defend their enterprise. And it's still not enough. But PSAPs do not have that type of personnel or financial acumen, and we're not going to. We need to find a way to create the same kind of infrastructure and approach for a fraction of the cost. And there is a way to do that. There are ways to realize economies of scale. The EC3 is one of those potential options. Pictured on the screen is our vision of what this might look like. This is a logical architecture. It does not have specific network elements. It was not intended to. But as you will note, it takes the proposed high-level flow from Working Group 2 and integrates the EC3 into it. The two-way arrows you see between the ESI IP transport, or the gray bar sort of in the middle of the screen, and the OSPs on the left of the screen, and the green box on the right, which is trusted partners, are two-way communications links. Those need to be trusted links. They are evidence of why it is so important that we share information from the local through the state and up to the federal level. I will give you an example of how effective this can be. San Bernardino was a tragedy that also proved to us that there are capabilities currently deployed that allow us to share in real time the health of 911 networks from the state level through regional and up to the federal level. In addition, they allow us to track incidents in real time, and were we to have experienced a cyber component to this or any of the recent attacks, we would have known about it as it occurred instead of after it occurred. The importance of that aspect cannot be overstated. A cyber vector to any of these attacks would have crippled response and could have led to a serious increase in the tragedy and the number of casualties. We cannot afford that. Cybersecurity is that important. One mistake can cost responders and citizens their lives. No one in our working group wanted that to go unnoticed or unmentioned. We believe cybersecurity is one of the most critical components to the overall response picture, and we believe that defending the entire enterprise is absolutely critical. Regardless of the architecture option chosen, there are ways to defend any or all of those using a cooperative approach. Also in this report, you will see that The EC3, in whatever form, can be implemented at multiple levels. There will be large PSAPs in large metro areas that decide to build this themselves, and that's fine. There will be sub-state regions that decide to partner and build this. There will be state-level folks that decide to partner and build these. There are commercial providers that offer many of these services today that can provide them on a cooperative and shared basis. All of that is on the table. We do not wish to take any of that off the table. Our suggestion, however, is that regardless of how you build it, you need to build it to the same standard, the same common communications protocols, and the same governance needs to apply. We need to share information. We do not need to build these in a silo. If you're going to build a cybersecurity center or system, it needs to be part of the larger enterprise, or we have completely missed the picture. Information sharing, as we have learned, is incredibly important, especially in a real-time incident. Let's talk about how we fund it. We just go to Congress and ask for a couple $1 billion, and they give it to us when we move on. Or we fight a really long battle, and we figure out a way to fund this at state and local levels, and we get help from the federal folks where it makes sense. And obviously that's the direction we have to go. There are a number of ways to partner on this and realize economies of scale. In the report, we give an estimate for what an average EC3 might cost. We focus primarily on operational expense rather than capital expenditure because CapEx really, as far as building out one of these systems, depends widely on where you build it and how you build it. You can certainly start from the ground up and build a whole new center and spend millions and millions of dollars on a brick and mortar facility, or you can do what many organizations have done and repurpose an existing data center or build out adjacent to a PSAP or do a number of different things. But the operational expense is a very much a reality for PSAPs. We have limited OPEX. And in order to operate one of these, we're estimating that an average center, minimally staffed 24 hours a day, 7 days a week, 365 days a year, will cost approximately $900,000+ to operate. Primarily personnel, of course, but there's also the deployment of sensors as well as the cost of monitoring those monthly sensors. That's for a small 2 to 3 person manned 24-hour-a-day center. Obviously, as the center increases in size and staffing, the cost goes up accordingly. The intent of our model is not to say you can do this for $975,000. It is to say here are some decision-making points for you to use as you figure out what you want to build and how you want to build it. And by the way, you can build this one time and share it between 100 PSAPs, and it'll cost you about $1,000 a piece a year. Or you can build it one time for each PSAP, and you'll pay $1 million a year. And yes, I know my math was wrong. There are a number of different ways to look at how we do this cooperatively, how we share not only the information but the infrastructure, and how we tie that into whatever architecture we choose to implement, because this works across architectures. It really doesn't matter which way you implement NextGen. This ties in specifically to the Esinet, which touches all of the other elements, to the OSPs, and to federal state trusted partners. All right, briefly, use cases. We talk about TDOS and DDoS, which have already been discussed. We talk about swatting, which is an ongoing problem, and basically that is spoofing an address and sending false information to a 911 center and getting an actual police, fire, EMS response on a non-existent incident. We also talk about a single PSAP being compromised and what happens if we can't protect interconnected PSAPs. And as you've heard, this is a network of networks. They are all interconnected. We can't defend just one. We have to defend the entire enterprise. So we need a plan. All 4 of these use cases are very real today. They are not just applicable to NextGen. The purpose of this appendix is to illustrate to the PSAPs why this is so important and to give them information that they can look at right now to understand the critical nature of the problem. Appendix 2, again, is probably one of the most important parts of the document. It is a combination of checklists and a roadmap for the PSAPs. It does not say every PSAP in the country has to do everything in this checklist and has to follow this roadmap. What it says is, here are the things that have to be done to defend your enterprise. Some of it most certainly can be done at the PSAP level and should be. Most of it will have to be done at a higher level. Many of those things will be handled by the EC3 and affiliated vendors or by the service providers and will be covered under those service level agreements. The important thing to note in the roadmap and checklist is these are all important things that need to be done, not necessarily by the PSAPs, but in the overall approach to cybersecurity. Appendix 3 is pretty straightforward. It's a list of resources for the PSAPs and for decision makers at the state and local level. The reason we've included it is, again, we must educate our emergency communications folks on the importance of cybersecurity, and we must provide them with some resources that are available today. Much as DHS did in their section, this section basically targets any available internet or other resource that the PSAPs could reach out to, read about, and then pick up the phone or send an email to and talk to. One of the things I want to note before we go on the EC3, and I've received some questions, I'm sure there will be more. We named some specific agencies. We named the DHS, NCC, and NCIC. We named the FCC, obviously, and we named the MSISAC. All of these agencies currently have a working relationship. They currently share information every day. They are examples of how the federal government is succeeding in sharing information, and more importantly, they are examples of how state and local, not only government, but commercial entities are sharing information into a joint system. The NCIC does this every week. The MSISAC, the same. These organizations meet weekly and work daily to share real-time information. In addition, the FCC Operations Center is tied in with all of the above. When we mention these, we are not suggesting to local governments that they must use them as resources, but we are suggesting they should consider it, and that talking to the NCIC and the MSISAC and the FCC is a good idea when formulating a cybersecurity plan. In addition, we do recommend that it is critical that the EC3s be tied into those partners in order to not only enable real-time sharing of information, but to bring federal and state resources to bear for PSAPs that would otherwise not have access to that. We've told the story several times of TDOS attacks occurring in a PSAP, and then 2 or 3 hours later, the attack occurring at the PSAP just to the north of the initial victim, and it taking 3 days for either one of those PSAPs to know that it had happened to the other. That has to stop. And we cannot effectively defend our PSAPs if we don't educate them and provide them with tools. These are opportunities to do that. So we're not suggesting specific approaches, but we're giving specific examples of situations where it works today. And it's something for PSAPs and 911 authorities and local and state decision makers to consider. I actually had to write the last part down so I didn't forget what I meant to say, and now I'm all out of whack. But we have a number of recommendations. I really don't have time to go into them because we've got about 10 minutes to finish up and take a procedural vote. The good news is that means y'all can't ask me a lot of questions. The bad news is that we don't get to go over everything I had hoped to go over. What I would like to close by saying is, first of all, on behalf of Working Group 1, I would again like to thank the Commission, Admiral Simpson, and your staff for the opportunity to have served on this task force. 11 months ago, we didn't know what we were getting into. 11 months later, we're not sure we know what we got into, but we're sure we've worked very hard to hopefully meet the goals that you set for us. We believe that we have delivered a solid foundational document upon which future work can be based, and that was our intent. Most importantly, what our hope is, as public safety professionals and practitioners and industry professionals who are involved in this enterprise, is that we have provided a solid set of recommendations, information, and options to the dedicated professionals of America's emergency communications centers, because it is they who remain ever vigilant, and it is they who stand ready to answer the call. And for them, we offer this report to the Bureau and to the Commission as our final product. And with that, I will close out my comments.
Thank you, Jay. As we did with Work Group 2, and recognizing that we still have some work to do here and not a whole lot of time to do it, does anybody have any questions that you'd like to ask of Jay? Roger.
Did you use the term PSAP in the generic sense in this regard? I noticed in the diagram, which I had seen before, of course, that you showed connections of the cybersecurity aspects to all parts of the process, including NG core services and things of that nature. Clearly, there are a growing probability of having centralized data groups that are outside the PSAP, unquote, engine and core services processes that are not run in the PSAP, unquote. Does the report deal in general with the fact that the whole enterprise, as you refer to it, is a cybersecurity related?
It does, and we specifically use PSAP and 911 Authority, both, not just one. Yeah. And we also talk about the need to defend the entire enterprise, and that's why the diagram specifically shows connectivity not to an individual PSAP, but to all elements that comprise that emergency communications landscape.
Yeah, okay, good, thanks. I was pretty sure I knew the answer, but I had to check.
Anyone else in the room? Yes, Phil.
Jay, just two quick questions. The cost estimates that you recommend is just a rough approximation of what a 911 authority or a PSAP could be, right? It's not one size fits all.
Absolutely. And specifically, the language you'll see in there says that the staffing would be 5 personnel and a supervisor, so that's minimal staff for a smaller type of EC3. It is not intended to be a one-size-fits-all or a one PSAP implements this 6,000 times. It's intended to show what it would cost to staff a center with 5 personnel at the appropriate professional level and a supervisor, to staff it 24 hours a day, 365 days a year, and to deploy the needed sensors and pay the monthly recurring costs necessary to monitor a moderate bandwidth. And we base that on some real-world dollars as well as the high end for what Albert-like sensors might cost to deploy. The reason we use Albert-like is because Albert is specific to the MSI SAC, but there are other options that are similar. We also use the Cal OES model, which is something that was proven to work during the San Bernardino shootings, and we did not include cost for that, but that cost is obtainable should folks want to move forward in the next iteration of TFOPA and take a look. But yes, it is a generic, high-level, not one-size-fits-all estimate, and it's basically to allow PSAPs to start looking at the fact that it may be smarter to share these resources and to build them one time and interconnect them than it is to build them many times and pay for them many times.
Phil Jones, Washington Commission. Second question is on this transition. I think, Tony, you talked about it, Working Group 2. My Working Group 3 spent a little bit of time on this, the cost of maintaining 2 legacy systems. So we know that it's going to be more costly than less costly. But from a security perspective, did the working group look at the riskiness or the vulnerabilities of a dual legacy system in a longer transition than we think?
No, and here's why. We have to defend both because both exist. So we didn't look at independent costs. The reason we broke it into those 3 sections was, 1, to show what needs to be done with an existing system and what is being done now. And we did not break out costs with that because, quite frankly, it's being done piecemeal. It's not being done very well. And we haven't paid good attention to cybersecurity up to this point. The approach has been very fractured. But the second half of that is to show what it might cost to defend if we do it in a collaborative and collective way, a next-gen enterprise, not just a PSAP, not just a single 911 authority, but the enterprise. But we did not look at the difference or at what the combined cost might be because, quite frankly, we have to defend what exists today, and we're already doing it. We're just not doing a very good job of it. But also, if we were to implement this EC3 approach now, it covers both the transitional and the next-gen models, which is one of the things we like about it. It does not require a forklift upgrade as a PSAP goes from transitional to next-gen to continue defending it using that EC3 approach. Basically, we could build those today, and they could defend both the existing and the future infrastructure along with the transitional. There would obviously be some tweaks made and some increases in staffing and bandwidth as we move to IP, but this is something we believe could actually be pursued in the near term and still be effective in the long term.
Thank you, Phil. Thank you, Jay. Any other questions in the room? Any questions online? Online, anyone? Back to Admiral Simpson.
Thanks so much, Jay. Really great work. Let me go to ICAM first.
But this is something we believe could actually be.
I think that you did a good job of outlining that FICAM isn't necessarily what is appropriate PSAP by PSAP across the country, but you also described in your articulation of an average PSAP where you've got a call taker that would have a name and password for the CAD and a different name and password for the Wave system for LMR and a different password for maybe the back office and a different password for Internet, that as we go forward and bring FirstNet in, there will naturally be multiple ICAM environments that need to have a degree of interoperability between them. There will also be then, when you expand that into the shared model and mutual aid agreements, be a need to share some degree of credentialing between networks. So there is a real need for ICAM interoperability and a definition of what interoperability of credentialing would mean across multiple networks.
Yes, sir. I fully agree, and obviously that's part of that trusted partnership and trusted connection between networks. And as was mentioned in Working Group 2, because this is a network of networks, inevitably we have to arrive at some common approach to that. Yes, sir.
Great. Okay. I think we've had initial discussions with Nina and the I3 folks that we may possibly initiate an effort around developing such an interoperability description. So we'll want to continue to work that with you. On the threat model, your Appendix 1 gave me concern because it's a fairly short list. It is oriented around legacy, but that's not the aim point. Right. If you look at the evolved threat model for a fairly realized next generation 911, it includes things like the exfiltration of data that would be embarrassing or contribute to a physical terrorist attack. It would involve the altering of data potentially, where you would change something critical to a response and have exactly the exact opposite of what you intended in a dispatch. It could involve altering of location data. So I think, if I read you right, that Appendix 1 just lets us know what we know Kidden got to fix today, but we ought not to keep our eye off the ball for existing threats that exist today in other IT systems that will, the minute we cross the Rubicon with Next Generation 911, also present themselves.
Agreed. There are two reasons that we did it that way. First, in the interest of operational security, some of those new vectors are not necessarily identified yet outside of certain circles, and we didn't want to give anybody any good ideas on how else to attack us. But more importantly, we wanted to relate to the PSAPs something they could understand today, because it has happened, and something that makes sense as far as getting their attention. In the EC3 section and in a couple of the other sections in the document, we do discuss some of those other threats. Fully agree and have briefed on numerous occasions those other threats as a very real problem for PSAPs. But because, with the exception of the extortion threat on the Bitcoin type stuff, because PSAPs haven't seen a lot of that yet, we thought it was probably easier and kept it more direct to show them threats that exist, to get their attention and understand the nature of cyber in general, and then follow-on work could absolutely
not
discuss it.
Yeah, you got it. I didn't see in the written report a concept that I think is important as we go forward, that is a natural potential defensive opportunity based on what Dave's group did. As you roll up the shared platform models and the hybrid model, there's an opportunity as you work out the mutual agreements between jurisdictions to architect in a way that segregates the risk of a full-on cyber attack, so that if you have a mutual aid agreement with essentially two Esinets, and one Esinet is completely taken down, as long as you're careful about not commingling the interfaces or having a higher degree of protections between the interfaces, you'd have a recovery opportunity through a mutual aid agreement with that other Esinet. And again, another reason for jurisdictions working together, and that would be a relatively low-cost way of having a stronger defensive plan that doesn't necessarily require a whole bunch of systems. It just requires some organization, some of that planning at multiple echelons up front.
I certainly think that's something that whoever runs with cyber in the next iteration would want to look at.
Yeah. You made the comment about small PSAPs, 3 stations and less can't afford to implement cyber in a meaningful way. And I know what you meant. I just want to make sure that it was understood. You're not saying that they can ignore the risk. No. The same risk is presented, right? And I think you said that their options for mitigating the risk are different. They will have to look outside their lifelines to mitigate that risk.
They have a limited opportunity to hire expertise into the PSAP, and quite frankly, we don't think they need to if they partner and look at the ability to create the physical and cyber defense systems outside of the PSAP. They will still be responsible, as identified in the framework that we present in the report, for training their personnel and for certain aspects of cybersecurity. Cyber hygiene will be the responsibility of every employee at every PSAP, but building the actual cyber defensive system does not have to be put on the back of every PSAP. So our intent is to certainly educate the PSAPs on the need to implement cyber at a certain level in every PSAP, but then to move into that sort of scaled approach based on their size and capability.
You identified the risk management framework, which I think is great, and then identified the PSAP as the body that then uses that to evaluate risk. And I think it's important to identify the risk owner. And I'd suggest that looking at some of the language from Dave's report in making clear that there's the PSAP authority and there's the PSAP, and that it's vitally important that the PSAP authority understand and accept and own the risk. The PSAPs, in some case, they're the victim here if it's not resourced right. But the ownership for that risk needs to be those elected officials or those appointed officials that make up the PSAP authority that decide whether to accept this risk, pay for it to develop capabilities organically, or pay for it through non-organic contracts and other shared operations. So I just want to make sure we're talking to the PSAP authorities. They have to own this risk.
Well, I think the issue there is that you have PSAP authorities in some places right now today you just have PSAPs. there are no 911 authorities in some areas.
Well, it's the person
So
who decides how
eventually-
much they give to the PSAP. And the PSAPs don't.
State of Colorado, that's the PSAP in the county they reside in, sir, with all due respect. So-
Absolutely, but the PSAP director doesn't write his own paycheck.
Okay.
It's the elected official that decides how much they're going to pay to the PSAP. I was just in Colorado Monday in Boulder with the state CIO. This is a big problem for them because as they look forward, relatively home rule state, right? They've got independent PSAPs, but as they look to the cyber challenge, they're pretty sure that they can't really get after that effectively if they're not involving the state CIO and having shared security operations at a statewide level. And that's hard because now you've got elected officials that are very happy with their local PSAP, but don't really necessarily understand or are ready to contribute to a statewide defensive effort for cyber. So that's why I'm belaboring this point, Jay, that I think we very much got to get to the elected officials or appointed officials with this responsibility and ensure they understand the risk and understand that they're the deciders on how that risk is mitigated. And the last point here, I did hear you say it would seem, and I'm going to paraphrase and let me know if I got it wrong, that in your work that you saw almost universally where it's being done an underinvestment in cybersecurity. But more often than not, no meaningful investment in a professional, reasonably capable cybersecurity program.
I think with the exception of larger enterprises that have money and have cyber expertise, and obviously those places pay attention to it because they can, the vast majority on the public safety side are not aware of the threat and they haven't planned for it, and because they're neither aware of it nor have they planned for it, they haven't spent money on it and they haven't implemented a cyber plan. And I think that from the PSAP perspective, that's simply because the threat has not been as prevalent, and it's not something we've had to defend against. But yes, it is our belief, and based on what we discussed for 11 months, that the approach is spotty at best, and as you said, either an under or no investment has been undertaken, and it is critical that we bake this in sooner rather than later. We shouldn't build ESI nets until we've already accounted for the security of those ESI nets, and the same applies beyond those into the entire enterprise.
Great. And last question for Dusty. It would seem that one of the useful things that the task force can do post the report in January would be to take a look at the security architecture and red team it and bring in some of the DHS experts and maybe see if Cybercom or the FBI would help via tabletop kind of event where, and I would suggest we do this non-publicly. So if you could consider that, and I think I'd want to work closely with our colleagues in DHS to set up such an assessment of what's the aim point for cybersecurity operations in PSAPs. Thank you.
Jay, before we move to a vote, I'd like to personally thank you, and I think I can have April Hines joining me 11 months ago when we began working with you. It's probably an exaggeration, but it was a struggle to spell cybersecurity. But with your guidance, we have learned a lot about it. So on April's behalf and mine as the PSAP directors on the committee, thank you very much. And to Admiral, thank you for looking out for us.
Yeah, thank you.
We're going to vote now. We're going to do this a procedural vote as we did previously with Workgroup 2's effort and with Workgroup 3 3 months ago. All in favor of accepting Workgroup 1's effort, signify by raising your hand. All hands are raised. On the bridge, anybody that wishes to not accept it, please say so. Hearing none, Workgroup 1 effort is procedurally adopted. And what that means is that at this moment in time, all three work groups have been procedurally adopted by this committee. Where does this lead next? In the wings, I hope, is still Jim Gerke. Are you still there, Jim?
I'm still here, Steve.
Thank you for your patience. It's been a long meeting, but at the same time, where we are at this juncture is, if you liken it to baseball, we're coming around third base and heading for home. and home is on the 29th day of January 2016. So we have a month and a few days, coupled with a lot of holidays, for us to pull the three work group efforts together in a document that will ultimately, on the 29th of January, be voted on by this group to accept in total. I have asked my good friend Jim to head up a editing committee, if you will, of some people that are in this room and others that are not. Jim has been at work already because they already had Work Group 3's procedurally adopted report to work with, and now we have two more into the hopper. Jim, I know the day is late and we're all anxious to leave, but at the same time we want and deserve to hear from you. So can you brief us on anything that you would like us to know?
Yeah, thank you, Steve. I'll make just a few comments, and I'll try to be as brief as I can. And by the way, at some point after this is all said and done, you and I need to have a conversation on how I ended up in this role. We've been asked or essentially charged by the Commission to pull the three work group reports together into a consolidated document. I think logically what I envision is a document that would have three major sections to it, each section reflecting one of the work group reports. Again, logically, there probably would be a consolidated introduction to that, and there would be a consolidated recommendation and findings section. I think, regarding that particular section, it's likely that we'll have, and this is what I see in all three work group reports, some recommendations that can, benefit decision makers and 911 authorities and other folks almost immediately. And then there will be some recommendations, or are some recommendations that deal with further work that could be done and would enhance the efforts in our products as we've produced them. Most immediately, I put together, I guess one other thing too, a work group to assist in this editing. I attempted to put together a group of folks from the task force that I think does a pretty good job of representing the task force. People that have been on all three work groups represent both the public sector and private sector parts of the task force, and most importantly, and I want to emphasize this, almost by definition includes the three work group chairs along with Steve and Dana. I think that's goes without saying. We have a pretty aggressive schedule, obviously, leading up to January the 29th, in order to come up with essentially what represents a recommended document for consideration by the full task force. That will require that we essentially have that draft probably by towards the end of the second week of January. That's pretty aggressive when you consider the holidays in the middle of all of that, but that's what we'll work towards. Almost immediately, the first thing on my agenda now that we have the three work group reports is to come up with a structure that will support what we've been talking about. I hope to have that done pretty quickly, probably by the beginning of next week. And then follow that up with a schedule that'll get us to the second week of January, and at that point we'll move on. So that very quickly, Steve, that's how I see us moving forward.
Thank you, Jim. Are there any questions of Jim? Jim wondered why I asked him to do this. And some of you know what I'm going to say, and some of you may not. But back on September 11th of 2001, there was to have been approximately 12 blocks from where we sit, a press conference on Capitol Hill at 10 in the morning, at which time Nina was to issue its 911 report card to the nation. We all know what happened before that happened. The press conference never occurred. 911 day was uttered no more. it became 9/11. If you look at that report, which was issued shortly after Thanksgiving with no fanfare of that same year, there were two authors of that report. One of them was our friend Jim Gerke, and another one was a gentleman that works in this building now, and he didn't work in this building or for the federal government at that time, and his name was Tom Wheeler. So, Jim, thank you for your past service, and that's why you continue to be asked to serve again. Thank you. Are there any closing remarks? First of all, thank you for your patience. The prohibition on breaks have been released. You're free to go. But have a safe trip home, a wonderful holiday season. Remember, the 29th of January 2016, we'll be back in this room again. And thank you again for all your help.